फाउंडर तो वही थे।
हाँ, लेकिन सैनी जी स्थापित करके गए थे ना। हाँ। स्टार्ट किया जाए बादल जी। कम आ रही, थोड़ा सा माइक और नजदीक कर लो यार।
वर्मा साहब 1 मिनट और हम लोग वेट कर दें, थोड़ा सा YouTube पर लाइव कर रहे हैं। इट विल टेक अनदर 1 मिनट सर।
ओके ओके ठीक है।
A very warm welcome to all the participants and the guests. Sir, it is a very innovative program that has been launched by KNIT and SPI Uttar Pradesh for the benefit of the students. A 5-day capacity building, a skill development program for the students who are in 3rd year and 4th year of their BTech programs. On this occasion, I heartily welcome Vice Chancellor Professor Binay Kumar Pathak ji, who has been kind enough to spare time to be available with us at a very early time at 9 a.m. Our another guest, Professor P.M. Khodke ji, Central Project Advisor, because of some urgent assignment, he has been delayed. And in his absentia, I also welcome him. He can join anytime. I also welcome Professor J.P. Pandey ji, I will say Director KNIT, being the organizer, and Vice Chancellor designate for Triple MUT Gorakhpur. I also welcome Professor K.S. Verma ji, Professor and TechUp Coordinator from KNIT Sultanpur, Professor Nilendra Badal ji, who is the Professor and HOD of KNIT, and Professor M.K. Datta ji, who is the Dean PGSR, Dr. APJ Abdul Kalam Technical University. I also welcome all the faculty, TechUp coordinators, directors, deans of various universities and institutions, more particularly 1.1 institutions of Uttar Pradesh. I heartily welcome all the students who have been participating in this program. Sir, in line with the Government of India directions and as communicated by MHRD and NPIU, the TechUp Institution Uttar Pradesh are taking all possible preventive and precautionary measures to ensure the safety and security of their students, whether on campus, in the hostels, or outside, confronting the COVID-19 pandemic. At the same time, SPI Uttar Pradesh and more particularly the institutions and Dr. APJ Abdul Kalam Technical University had taken all the measures to continue teaching, learning in an online mode, and all other efforts are also being taken for testing, assessment, and examinations. KNIT Sultanpur has been an autonomous institution under UGC and still having the autonomy from the Dr. APJ Abdul Kalam Technical University. When the proposal came from various corners, I discussed with Professor J.P. Pandey ji, who agreed in a minute for this program. Sir, this program, Artificial Intelligence and Machine Learning, has been conceived and designed by SPIU in collaboration with Professor M.K. Datta from Dr. APJ Abdul Kalam Technical University. This will be a 5-day program and will continue daily from 9 a.m. to 1 p.m. So this is the first program on such a wide scale is being conducted. If this will be successful, SPIU may move forward collaborating with other institutions for conducting similar programs in various other future skill areas. Sir, future skill is one of the major domain and mandate of TechUp3, and large number of faculty across the country, including from Uttar Pradesh, has been trained in various domain area, and they need to conduct online training program as per the mandate given to them in all these future skill areas. The objective of SPIU to collaborate with various institutions is the knowledge transfer, and we are calling all such programs a knowledge transfer series. So under knowledge transfer series, this is the 5th program, and many such more programs will come forward. On this occasion, once again, I welcome the Vice Chancellor, Professor Vinay Kumar Pathak ji, who has been a dynamic personality, a great leader in the field of technical education, a great motivator for the faculty, administrators to immediately jump to the online learning. So with these few words, I request Professor Vinay Kumar Pathak ji to kindly bless the students and guide us so that successfully we can conduct this 5-day program, and the first program ever being conceived and organized under TechUp3. Welcome to Professor Vinay Kumar Pathak ji. Welcome, sir.
Honorable and the designated Vice Chancellor of the Institute, Professor J.P. Pandey ji, the other colleagues, the ex-director, Professor Verma, Mukesh Singh ji, the head of the department, Dr. Neelendra Badal ji, and the other professors, and my own other colleague, Dr. M.K. Datta, and Anil ji, who is mentoring and making this lockdown a kind of a story from all the parts, trying to do a lot of innovative works. Welcome to all of you. I think it's a great initiative, and an initiative taken by SPIU, although the SPIU always takes an initiative. But to me, having this kind of a course on artificial intelligence and machine learning is a great kind of an initiative done by Anil ji. And also, it was well accepted by Professor J.P. Pandey ji. I think the next era belongs to AI and deep learning and machine learning. And it's all fortunate for all of us that among this state, we have got a very good person who works in this area, have published a lot of papers, and who is now the Dean Research of the university, Professor M.K. Datta. I think the students have got a very, very large capability of doing the things. The only thing in the government institutions, we have got an excellent faculty, and we have got excellent quality of faculty. The only thing is that we are lacking initiatives. We are not able to change our courses, course curriculums according to the new technology. I think just like a COVID kind of a thing which has come, we have done a lot of work in terms of online studies. We have done online classes, but there are also the research collaborations, and all of the, if you look to all of the foreign university and foreign institution and the leading institution, they are also doing a great work. In fact, they are doing great work in the kind of the initiative they have, and they are trying to do the research problems which is coming. I think our institute lacked those kind of things. I think this is a new course which not only the faculty member, but students, but faculty members should learn and try to implement in the course curriculum. Because if you look to new area, then I always say that the new area or the new thing will belong to the artificial intelligence and machine learning. Maybe electrical science, maybe electronics, maybe textile, maybe computer science, maybe all will have the applications of AI and the machine learning. I think last some few months, I became a student of Professor Datta, try to understand what he's doing, try to understand things. And I thought that In every area of engineering, Professor Datta and his colleagues and all other people should deliver a lecture. The artificial intelligence and machine learning is going to impact that area. I have also requested him to make a MOOCs program or do. Recently, he has launched a course where he has got only 50 students, but 10,000 students applied for that kind of a course, which was a great success. I think I will also urge Dr. Badal and his team in KNIT. KNIT was a great institution, is a great institution, but we should also be producing and doing a lot of new initiatives and a lot of new things. We cannot harp and we cannot reap now the institutions on the basis of its name. Its name is like we used to in Kanpur, and I used to say, लाल इमली का कंबल कब तक बिकता रहेगा? लाल इमली की घड़ी चल रही है, कंबल चल रहा है, तो ओसवाल का कंबल आ गया, कैसे बिकेगा? तो इंस्टीट्यूशंस जो नए हैं, जो सुल्तानपुर है, जो भी गवर्नमेंट इंस्टीट्यूशंस हैं, because the institutions around them are moving so fast. If you look to any private universities now, they will have all these courses. They will have BTech in machine learning. They will have BTech in artificial intelligence. They will have BTech in data sciences. So we are doing as a government institution, is Dr. Badal and his team at KNIT is doing something. They are doing some courses for the students, or we are trying to do the old databases, old kind of things, and old. These are very, very new questions. And I think the SPIU and the TQ program is meant for doing these new kind of technologies. Because this program is among all of us, all of the faculty members are there, I want to urge that there is a new need of doing the technology. We are government faculty members, but our institutions will only remain if we will learn ourselves new technologies and our students learn new technologies. Suppose tomorrow a student is doing a program in Python, programming in Python, or they are doing in some things in R programming. If they have got a problem, who will going to help? They have to go outside and learn some tutorials, because none of our faculty member is trained and not they are doing any training in that kind of an area. So I think this is a new time, and I will request Professor Datta also not to do only one courses, but if there is a collaboration, and if the Sultanpur guys or any other engineering colleges guys come to this program after doing this thing, and if they want to collaborate with the research problem, let us make a new areas of doing the things. Let us make a new areas of having this kind of a consortium and doing this kind of a researches. If all the government faculty members will not unite and stand in doing new areas of technology, I think I always say that, and I want to say on this platform also, it will not be very long that we will become like an extinct like dinosaurs, right? So you see, there are now 700 colleges have come. Out of those, 25 colleges are doing very well. They are adopting new technologies. The only thing is that they don't have so many good students and so many good faculty. But once this threshold is changed, I think the government institutions will become extinct, and they are becoming. And believe me, the kind of placements which was 20 years back or 15 years back, the kind of name which we have, the kind we are struggling for NBA, daily the Anilji is telephoning us for those kind of things. I think those things we have to look and make these government institutions institutions of a place of learning, a place of higher learning, a place of research, a place of research kind of thing. Otherwise, the next generation will not avail such kind of good opportunity. So it's a challenge. And it's a challenge in new technologies. It's very good that this course was organized. It's very good that Anilji has taken initiative. Datta Sahab is also trying to make one of the best lab in the country on the artificial intelligence. He's trying to buy 2 DGX servers, out of which we will give all the facility to all the students for the company. But to me, we have to be of a new idea. When I talk to the students of our colleges, they have got a lot of ideas. They are doing a lot of programming, but they need mentors. I think this course will make new mentors. This course will also try to make a new kind of paradigm. I hope that the things will happen, and this course will lead into a new thing. In the last also, when this course will be concluded, I will try to come once again, see that what kind of things. But one thing I want to say to Dr. Datta, while he's conducting a course, please do take tests, please do take reviews, and please do also mark the faculty members how much they have learned. And after that also we should monitor whether they have applied to their institutions or not. It's always good to have courses online, because there is no bag, there is no lunch, there is no certificates. So these three motivations, so really people who are interested have really joining this course. I want to say once again, thanks to Anilji, JP Pandey, our colleague KS Verma Saab, the Nilend Badalji, and all other people of KNIT who have launched these courses. But you need to launch so many courses of this kind. You have to put students on so many hands training. This is all what I can say. Nilend is also with our one of the deans. So I will expect that he will launch such kind of courses and launch such kind of things for all of us. Thank you very much.
Thank you very much, sir. Indeed, you have been a great leader, a great mentor, and a great guide. Under your guidance, on a regular basis, AKT is attaining more and more bigger heights. And we are happy to hear from you that you are going to ensure establishment of a lab in the field of artificial intelligence and machine learning as one of the best in the country. Thank you very much, sir. And I do hope other institutions will follow what Professor Pathak ji has told, that many more such courses have to be designed and implemented in future skill areas. SPIU is a facilitator, and we are ready to provide all facilitation to all institutions. And I once again request, particularly KNIT, one of the oldest institutions.
अच्छा मैडम तो कह रही थी कि WhatsApp कॉल पे कर लीजिए, वीडियो कॉल पे. अच्छा सर, मैं गूगल मीट पे कर लेता हूँ.
VC साहब अपना म्यूट कर लें सर.
ठीक है सर. मैं
So I will request and expect also from KNIT, they have to come forward. All the faculty have to design the programs in the respective domain and come forward. And SPIU will not be even an inch away from them in jointly implementing. So let us take a pledge that we will be conducting many more such programs in days to come. With these words, I will now like to introduce Professor JP Pandey ji, the director of the KNIT and Vice Chancellor Designate of MMMUT Gorakhpur. He has been a vast experience in various areas of education as a faculty, as a teacher, as a controller of examination, as a technical education administrator, and as a leader. Sir, Professor JP Pandey ji, can you hear me? So I will request KS Verma ji, kindly connect him. Probably he is not here. He could not be connected. And ensure that he is connected. Meanwhile, we'll move forward. The moment he'll join, we'll ask, request him.
I will ask.
Already, VC sir has explained that how, in a beautiful manner, AKTU is moving forward to ensure one of the best lab of artificial intelligence and machine learning in the country, in the campus. And the person behind it who is implementing it is Professor M.K. Datta ji. Professor Datta is a professor of the computer science and engineering. He is the Dean R&D and Industrial Consultancy. He has co-authored 255 plus index research papers in international journals and conferences. He was involved as principal investigator for 500 research projects and has also filed 5 patents. He has guided 3 PhD students and 3 are ongoing, 21 MTech dissertation. He has a strong international cooperation with scientists from USA, UK, Canada, Australia, Spain, Czech Republic, Korea, Costa Rica, and many more. He was a general chair of International Conference of IEEE Signal Processing and Integrated Networks. He is the reviewer in the reviewer panel and editorial panel of many prestigious journals. Professor Datta headed the ASET Noida, and under his leadership, his institution has secured 34th overall ranking and 19th position in research category in MHRD NIRF ranking framework. His area of interest is image processing, computer vision, pattern recognition, medical informatics, audio signal processing, and many more. Without taking any much time to explain him, because he is a well-known personality in the field of artificial intelligence. Very recently, a one-day webinar conducted on application of artificial intelligence to the medical science has been widely appreciated across the country, and the person behind that webinar was Professor Malay Kumar Datta ji. I will request Professor Malay Kumar Datta ji to kindly give a brief outline. First, you kindly introduce the topic, what for, what is objective, and a complete outline of the entire topic. And you are free to have your own time, extending up to 15 to 20 minutes, sir. Thank you very much, sir. Welcome you.
Okay, so good morning to all of you. I hope my voice is clear and my video is also visible.
Yes, sir. Yes, sir.
Okay, so good morning. Thank you all for inviting me for this workshop on artificial intelligence. First of all, I know our own Honorable Vice Chancellor, sir, who is over here, Professor Vinay Kumar Pathak. He has been a great leader, putting things in place, and he's always ahead of his time. I mean, the speed and the aggression with which he works is hard to match for people. So it has been one of his personal initiative, taking up latest technological interventions in our university. So I would first like to acknowledge and thank Professor Vinay Kumar Pathak, our own Honorable Vice Chancellor, whose incredible leadership is moving things very fast. My colleagues, and of course, the SPA, Anilji, you have been doing a great job in putting things in for knowledge dissemination and knowledge transfer. My colleagues from KNIT Sultanpur, Professor JP Pandey, students, participants, faculty members, welcome to this artificial intelligence workshop. This will be a sort of a boot camp, when we will try to discuss something from the scratch, start telling you what is artificial intelligence, what is machine learning, what is deep learning. We understand that there are students from second year and third year also. So we'd like to keep the delivery content of this workshop in such a manner that we'll start from the scratch, even from deep neural network or machine learning or supervised learning. We'll try to cover the basics, take you to the building of the libraries and implementing them in a software with hands-on sessions. And we understand that this 5 days boot camp gives you a complete and comprehensive insight on artificial intelligence and make you prepare, to take up more challenging projects. Of course, beyond this boot camp also, there are advanced courses or advanced training required, which you can always register later if we float these kind of courses. To give you about a glimpse, or to give you about a framework or a summary of how this course is going to run is, okay, before that, let me tell you what is artificial intelligence. If you really see, the world today has gone towards extreme automation of things. If you go 20 years back, buying a railway reservation ticket, or if you go for a flight ticket, or you want to pay your electricity bill, or you want to pay your car insurance premium, or whatever you say, there was so much of manual intervention, and it was actually desk-to-desk service. Today, if you see, last 15 years have seen incredible conversion of the real life into online mode. Things have changed, and they have incredibly changed in a very fast manner. Today, paying a car premium, or paying electricity bill, or anything. You talk about buying a flight ticket or a railway reservation. We are no longer dependent on a manual intervention. The automation has come up. Let's say from 2000 to 2010 was a time when online conversions and online transformations of every day-to-day life things have taken place, and people initially were resisting to it, that online is not a good method, whatever, and finally we all got adapted. Now let me tell you, the next decade belongs to artificial intelligence. So there is absolutely no doubt that the next electricity, the way we are dependent on electricity, the way we are dependent on internet connection, data connection in today's world, 5 years from now or 10 years from now, you will be dependent on artificial intelligence and its applications. The range of application of artificial intelligence is so wide that it covers all kinds of activities of your life and all kinds of studies, including engineering, science, mathematics, physics, chemical sciences, physical sciences, molecular sciences, nanosciences. So absolutely there won't be any place, even management, even HR relationships. So nothing can actually remain untouched from the power of artificial intelligence. And this is definitely the future. Now, if you ask me what is artificial intelligence, in very simple words, I can tell you it's a process where you train the computer without explicitly programming it to mimic the human behavior. The way the human brain thinks, the way the human brain interprets a situation, the way a human being looks at an object and makes a decision, the way a human being hears a sound and make an interpretation, we are trying to mimic them, and without explicitly programming a computer, we try them to understand and behave like human beings. Just imagine, I'll tell you one of the most fascinating, because most of the guys are young students. I'll tell you one of the most latest applications of deep learning. Now, in MIT, there's a company called NVIDIA. There's a project running in MIT in collaboration with the industry, NVIDIA. They are already making a driverless car system. And that car is traveling at a speed of 60 miles to 80 miles per hour. Now you can imagine, just make a comparison, how once a driver is driving a car in a highway at 80 miles per hour, just imagine the sequence of events that is happening. The driver is driving at 80 miles per hour, so there are turns, he has to apply the brakes, he has to use his legs for the brakes, the clutch, the gear, then the accelerator, the steering to actuate the directions. He has to look if there is an obstacle, accordingly he has to apply the brakes. And please understand, everything is going on real time at a speed of 60 miles per hour. Now, if you really want to integrate and implement this for a computer, for a machine, just imagine how much computational speed you require, how much information processing speed you require. Just imagine a car is traveling at 60 miles per hour, and all of a sudden there is a cow or a buffalo or an animal coming in just in front of him. And just imagine that the driverless system has to interpret there is an obstacle, accordingly actuate the brakes and make it stop. So, the way, let me tell you how it works. Let's say a human being looks into the road. His eyes are his vision sensors. In the eyes, the sensory signals are reflected. From the eyes, the neurons are fired. There's a sequence of neurons. The neurons will be fired from one to another, and go to the nervous system. It'll reach the brain. There's a portion in the brain called as the cortex. At the cortex, you will interpret that yes, there is an obstacle. And then the legs or the hands will make the actuation. The hands will, the legs will apply the brakes and the clutches to stop the car, and the hands will make according movements. Now, please understand how to interpret this and integrate this in a computer. The similar system, the computer will have a camera. The camera, and please understand, in a camera there will be, let's say, a normal video will be running at 30 frames per second. So you don't have, you have less than 1/30th of a second to interpret a video frame. How fast is the processing? Just imagine. Let's say there are 30 frames per second. It means you are left with an option of only 1/30th second to interpret a scene, to find out the objects in this scene, and then take a decision accordingly. And the entire process is not only about identification of the object in the video frame, but also taking a conscious decision whether to accelerate, whether to brake the car, whether to clutch the car, whether to actuate the steering, whatever. So this transformation, if you really imagine that how this transformation of artificial intelligence has taken place, and all of a sudden, let's say from 2015 till today, we have seen amazing transformation. Of course, till 2010, we had supervised learning like supervector machine and naive-Bayes and random forest decision tree regression models we had, but those models were not so fast to make things so so much computationally fast, and massive parallelization was not possible. So all of a sudden, in the last 5 to 7 years, you have seen there is revolution. Let's talk about a few more examples. Let's talk about Amazon. You can get into a marketing portal and you start purchasing something, and you can see how much the website keeps reminding you about purchasing similar things. The recommendation system, the online recommendation system, it's a robot. It's a robot which is programmed. And you need to understand that this robot is understanding your choices. Even Google, if you look into Google, whatever choices you make or whatever websites you visit in your Google browser, in your web browsers, it seems like that the web browser is remembering it and inputting your preferences and choices, and actually is giving you some kind of a recommendation. And that's actually scary because it's actually invading into your privacy. But anyway, you can understand the power of that artificial intelligence in recommendation system. Let's talk about drug delivery. Let's talk about medical informatics. I was involved with some of the projects which if I get a chance, I'll show you some of the projects we did. Today, in a country like India, please understand, in a country like India is struggling. A country like India is struggling with lack of proper medical doctors, proper qualified professionals. If you go 100 miles from Delhi or 100 miles from Lucknow, you may not have a specialist doctor. You may not have a specialist cardiac surgeon, or you may not have a specialist pulmonary doctor. You may not have an eye specialist. You may not have a proper specialist doctor. So that gives you more responsibility, because you're young guys. You have to understand, and you have to at least make screening mechanisms. There are amazing screening mechanisms and diagnostic tools that are coming up in present days. Even I work at least in at least a dozen of such technologies. Currently, I have a DST funded project where I'm trying to make a intelligent kind of a machine using deep learning like artificial intelligence, where a machine will detect the heart sound and will tell you whether the heart sound is normal or abnormal. Also, if it is abnormal, it will go beyond and tell you what kind of diseases it is related to. 5 popular diseases and common diseases we have considered. Similarly, the lung sound, the lung murmurs can be interpreted in terms of pulmonary disorders. So if you understand, if you can make this kind of devices, the country will be blessed. If you go 100 miles from any particular major city or 50 miles from any major city, there is a shortage of medical doctors. So this is how you can intervene. This is how you can make a technical intervention in the life of people in providing at least screening softwares. Of course, you must be knowing that our team, and from AQTU, and doctors from KGMU and some more hospitals, we made a screening X-ray screening framework for identification of COVID infection. So that was also interesting because it's currently in the clinical trial stage, and once this comes up, that'll give you enough opportunity to screen people in massive. It screens a patient, less than a second. So that's the power of technology. You talk about drug development, you talk about recommendation system, voice enabled system. Today you must be knowing, you can dictate a computer and the computer starts typing. The voice recognition system has become so powerful. You can type to a computer. You can use your voice to open and lock a computer. The voice enabling system. The face recognition system has become so popular. Big players like Google, Facebook, they have actually used the face recognition system, and very easily they can recognize a face from an image frame. So all these things have become possible only using very powerful CNN tools, deep neural networks, like convolutional neural network, which are going to study here. And the applications is infinite. You talk about any stream, you talk about nanotechnology. Let's say you are a nanoscientist. Even in a nanoscientist, to understand the structure and the physical and the chemical properties of your nanoparticles, you can use artificial intelligence. Well, how does it benefit? Now, the next question is, how does it benefit? You see, artificial intelligence is performed by a computer, and the computer never gets tired. If you have specialist computers, a good processing computer, massive parallelization computers, a computer would never get tired. Like, unlike a human being, let's talk about a doctor. A doctor has a limit. A doctor can screen 50 or 100 patients per day. You cannot exceed that limit. But a computer is a robot which would never get tired, and you can load the computer with infinite and unlimited amount of tasks, and it keeps doing. And that's required for humanity, for social, for social relevance. And if you want to contribute to the society, you can actually make this kind of tools. And technology can reach the remotest part of the world, where at least the screening part of clinical or medical problems can be done. Besides that, let me tell you some examples of artificial intelligence. Let's talk about, malware is a huge challenge. You must be knowing that a lot of apps are coming up. It's trying to invade your data, privacy. So how do you, actually take care of malware? If some guys of you are interested in cybersecurity, you need to understand that machine learning, deep learning technologies gives you enough opportunity to understand the features of a software, of an application, of an app, and actually will you can design cybersecurity protocols using artificial intelligence where that security threat attacks can be controlled. Some of my students are also working on that across the world. You can see a lot of work is going on. So for cybersecurity guys, also deep learning seems to be an ultimate solution where you can prevent unauthorized access and unnecessary security threats. Now, if I ask you a question, let me tell you in 1958, I'll show you in my slide also, there was a guy called Arthur Miller who actually gave the first definition of artificial intelligence. His computer started playing. He used a IBM 701 machine to play checker with the checker champion of that time, maybe 1962. And first time the computer defeated the champion. And that was the start of a story. Artificial intelligence beat the human champion. That story started. So the backpropagation algorithm and the multi-perceptron model was introduced in 1974, and then you can see the backpropagation came in 1975, I think, and even the neural network concept came in the 1980s. So if you really understand, if a question comes, if all these things were available in 1974 and 1984, how all of a sudden in 2015 and 16 and 17 and 18, there's a resurgence of this deep neural network. What was that so special that artificial intelligence became so popular and it started getting applied in all parts of your life, in all parts of study? What was that? To answer this question, remember, there were three important reasons. There are three important reasons which has made this deep neural network very popular, extremely popular in the last 5 years. Point number one is, the emergence of extremely, powerful, massively parallelizable processors from companies like NVIDIA. This was point number one. That the GPUs of NVIDIA have got a technologies like CUDA technologies, and they can massively parallelize a task, which you're going to study in this, of course, in this summer training. And that gives you amazing power to distribute the task among multiple GPUs or multiple computers and process them with very, very high speed. So this was the first factor responsible that came into picture. The second thing was the available of big data. Now, if you go 10 years back or 20 years back, you can't think of GBs. Your computers also came in, let's say the hard disk of a computer is only 1 GB. And that's what the data speed, that was the data limit. Today you have got drives. Today you have got online clouds where, hundreds and thousands of GBs we're talking about TVs now. So these deep learning networks and these convolutional neural networks are actually hungry for data. They're hungry for data. The more amount of data you feed them, it becomes more and more intelligent to understand and interpret situations and take decisions automatically on their own with improved accuracy. So the size of the data, because over the cloud or over the distributed networks, we do not have any problem in storage of the data, and that gives you enough opportunity to make incredibly fast and accurate deep neural networks. And the third point was the emergence of software tools. I don't know, you must have heard about tools like TensorFlow. TensorFlow is one of the very popular model. You have, PyTorch, even Microsoft pumped in a tool called CNTK. So all these, advanced architectures that came, darknet. I don't know if you know, people have proposed many things like darknet, and there are many, even the inception model, the Google has come up with the inception model. So all these models which are thrown by the big players, the architectures that are available, that gives you unlimited opportunity to young guys like you. So young students like you today is not limited by its size of the data or the availability of a high-speed, massively parallelizable processor, or advanced software tools like PyTorch and CNTK and inception model. I think Google, we will show you in our sessions also. Google, we have the Google Colab. You must be knowing there is a GPU called Google Colab. They're given for free. At least young guys like you can use them. Of course, as our Honorable Vice Chancellor has mentioned, we are coming up with a very high quality and a very, maybe one of the best labs in the country. We will be having 2 servers of DGX2, where computing will not be a challenge, and parallelization of training will not be a challenge anymore. So when all these 3 things, the size of the data, unlimited, availability of high-speed parallel GPUs, and the advanced tools like PyTorch, PyTorch or TensorFlow or CNTK or inception model, which is actually accessible to young guys like you, you have unlimited opportunity to unleash the creative imagination that lives inside you. See, you students are young students. Your mind is filled with innovative ideas. The level of your creative imagination is very high. Whatever you think, these artificial intelligence tools will definitely give you wings to implement your ideas. And absolutely, there is nothing. There is unlimited. The journey, I tell you, the journey of any innovation is a journey of excellence. So my message to the young students is always, this journey of excellence is unlimited. You give wings to your imagination and creative imagination, your creativity, your innovative things, and powerful tools like artificial intelligence, deep learning and machine learning will definitely assist you to achieve everything whatever you desire in terms of innovation and technology development. And let me tell you, maybe my final statement: this journey of excellence, this journey of innovation is unlimited. The only journey that is, the only limitation or the only limit is the limit that you have your mind. If your mind is open, if your mind is clear, if your mind is, do not admit any defeat, if you are indomitable spirit of applying the modern technology in making inventions for solutions, it becomes an unlimited journey of excellence for you. So thank you so much once again for taking interest in this workshop. We will have sessions. I'll take the first lecture today, the introduction lecture on machine learning. And as we go ahead in this 5 days workshop, we'll try to train you with hands-on and theories also. And we hope that next 5 days, it will be sort of a boot camp where you become more equipped with artificial intelligence. And I hope that this will be quite useful for you in your academic and professional life. Thank you so much once again for listening to me and giving me the opportunity to talk to you. Thank you.
Thank you very much, sir. Datta Sahab, indeed, you are a pioneer in the field of artificial intelligence and machine learning so far as Dr. APJ Abdul Kalam Technical University in Uttar Pradesh is concerned. And I believe with your efforts, a large number of faculties and the students will be skilled, re-skilled in this new future skill. Now, one of the co-organizers for this program is the KNIT Sultanpur, and it is very, in spite of the best effort, the director of the KNIT, Professor JP Pandey, could not connect, but he is available on telephone. I once again tell you that Dr. JP Pandey has vast experience in all the area of learning, teaching, in examination, in technical education administration, and in general administration. He has been already identified and notified by the Office of the Governor, Chancellor, that he will be the next Vice Chancellor of Triple MUT Gorakhpur. So I will request Professor J.P. Pandey as the Director of KNIT. It is your program, it is your baby, and we are expecting many more programs in days to come in in a collaborative mode, or independently KNIT can take lead to create an enabling mechanism where such programs are being conducted by each of the departments. I will request Professor J.P. Pandey, you can address over telephone. I am keeping the speaker on. J.P. Pandey, please.
Thank you, Ji, and thanks all the organizers of this webinar, which is conducted for artificial intelligence learning. In the effort of SPIU during this COVID crisis, they have conducted so many webinars on different topics, keep on going day-to-day basis, the development and educating the people and students in all. So first of all, I am thankful to Dattaji. He has given time for us. This is a KNIT initiative program, collaborative program with SPIU, and for that the whole team of SPIU is thankful for us to organize this webinar. Dattaji is my guide also. We are taking some lessons from him. He is a very educative person, giving education in a very formal. So for this webinar, my best wishes to all the participants will new learning from the expert people who will deliver this webinar for 5 days. Hello, are you getting?
Yes, sir. Yes, sir. Yes, sir. Please continue.
Yeah. So for this, since I'm sorry, I'm not in a position to connect me on this video mode due to some technical issues. So my best wishes is for this webinar conducted by SPIU, KNIT Sultanpur, and for this the resource person is like Dattaji, who is definitely very, he has worked a lot during this COVID crisis. So many milestones he has set for the state of UP as well as the country, and definitely the organizer and the participants will take advantage of it. Thank you, Anilji. Thank you, all the participants connected with us. I asked K.S. Vermaji how many persons are connected. So he is saying more than 500 people are connected. It is very nice. And for this, I am personally thankful to the SPIU team. They have insisted us to organize this webinar. And although KNIT is a very old institution, they are having very good faculty members, but due to some reason, they have not conducted so many webinars during this period. So this is the beginning, and all the best for all the organizers. Thank you.
Thank you very much, Professor J.P. Pandey. Thank you very much to become the part of this big initiative, and probably the best initiative ever taken by any of the SPIs in whole of the country. NPIU has identified 13 new and emerging areas. In the words of NASSCOM, they are calling it as a future skill area. One of the area is artificial intelligence machine learning. They have already trained large number of faculties, and they need to retrain, they need to skill and train faculty and students of their institutions and adjoining institutions in those future skill area. So without waiting them to take a lead in the area, we have taken the lead, and I am very happy to share that KNIT has joined hand together and will be joining hand together for many more programs of similar nature in days to come. Thank you very much, Pandey Sahab. Thank you very much. Sir, now I must share with you that second newsletter, SPIU has already started publishing newsletter on quarterly basis. During the COVID pandemic, the second newsletter has been delayed, but it is ready for release. And if DC Sahab is available, Professor Binay Kumar Pathak ji, Vice Chancellor, Dr. APJ Abdul Kalam Technical University, if he is available and he is online, I will request him to kindly formally release by declaring that the second quarterly newsletter of SPI Uttar Pradesh is being released. Professor Pathak, sir. So probably Professor Pathak sir is not available. In his absentia, we are formally releasing the quarterly newsletter series 2 of SPI Uttar Pradesh, and shortly each one of the participants on their email will get the copy of the newsletter and will be circulating it. Thank you very much. And with this, we are moving forward for the closing remark of the session. And for the closing remark and vote of thanks, I will request Professor K.S. Barmaji. He is a professor, former director, and take-up coordinator of the KNIT. Professor K.S. Barmaji, with your words, with your blessings, and with your guidance, we do hope that the participants will move forward to complete this program in a very flawless and effective manner. Professor K.S. Barmaji.
Right. Good morning to everybody. Naturally, this AI technique is very useful in all engineering applications. I am very much thankful to Dr. Anil Kumarji, SP Uttar Pradesh, his team, especially Dr. Narupa ji, Surana ji, VK Singh ji, for putting a lot of efforts for the professional contribution in the technical education as well. Teaching and learning is enhanced with the organizers' online workshop to the researchers, faculty members, and students. And my humble request to all researchers and faculty members, students, is that you should apply AI techniques in your study, in your research papers, and you should must publish in reputed journal like IEEE Transactions. Naturally, more in a 1 year, more than 30 research papers in Uttar Pradesh is being published in this area, in which AI techniques is applied in electrical engineering, civil engineering, mechanical engineering, computer, IT, and so many branches of engineering. A lot of thanks to Honorable Vice Chancellor Professor Binay Pathak ji, because his able guidance and suggestions, we are putting a lot of efforts in revising the syllabus and curriculum of engineering, in which we have incorporated AI techniques in almost all the branches of engineering. I am very thankful to Professor Pandey ji, who is our director, KNIT Sultanpur, and very good academician and researcher. And we have a lot of research students jointly research who are doing a lot of in the area of AI application in electrical engineering. A lot of thanks to Pandey ji. I am very thankful to Professor Nilendra Badal and especially Dr. Narupa and especially Dr. Anil Kumar ji, who has taken a lead in improving the teaching learning through these online workshops and seminars, webinars. Naturally, these webinars do help a lot in putting a lot of research papers in good journals, as well as researchers can have a patent in this area, because new techniques is evolving day by day. I am thankful to all the experts members, especially Professor Datta, who is taking lead in this AI techniques that will be useful for all students, faculty members, and students. Ultimately, all thanks goes to all the people who are associated with the online course of 5 days, and be sincere in attending the course. Please make a note and please have a discussion. Please have a hands-out training, and I think you will be very beneficial in applying the AI techniques, and your research will be completed. Thank you very much, Dr. Anil Kumarji. Thank you very much for leading the Uttar Pradesh and giving us a platform to have a good research and teaching and learning through TQ third project. Thank you very much.
Thank you very much, Professor K.S. Verma ji. It will not be justice if I will not mention especially my team members who have been constantly behind the scene and making all the efforts for last 3 days, day and night. Dr. Mahabir Singh Narupa, he has been the coordinator of this program on behalf of SPIU as well, and he's the nodal officer. Mr. Vinesh Surana ji, nodal officer procurement, and Mr. VK Singh ji, nodal officer finance, all have been together working for last 2-3 days time to make it this program to this level. And I do believe if a student takes keen interest and they are happy after closing of the sessions, I believe that our effort has been successful. Once again, a special thanks to the entire KNIT team under leadership of JP Pandey, TechUp coordinator K.S. Verma ji, and HOD of Computer Science and Engineering Department, Professor Neelendra Badal ji, who is the coordinator of this program on behalf of the KNIT as well. Now, with these words, this is the closing of the inaugural session. Now moving to the technical session. I will take, sir, with the permission of from Mr. Malay Kumar Datta ji, I will take only 2 minutes more, and then I will hand over the mic to you, sir. Sir, it will not be justice if you will not mention the other experts as well. The entire program is being conducted under the leadership of Professor Malay Kumar Datta ji. Along with him, his team members are, I'll be especially mentioning them, Mr. Neeraj Baghel, Ms. Soumya Yadav, and Mr. Rakesh Chandra Joshi ji. They are involved in high-level research in the field of artificial intelligence and machine learning, along with Mr. Datta ji. So the entire program has been designed in such a way that 4 hours in a day and 5 days for the complete program. So it is a 20-hour program, 1 hour each, and each expert will be conducting 1 hour program. Depending upon the feasibility, there will be a hands-on session on each date as well. And Professor Datta ji and his team members will be conducting each session on each of the day. Now over to Professor Malay Kumar Datta ji. Now it is up to you to plan and implement it. To you, sir. And once you start, we may go off also after some time.
Okay, thank you all for the introduction. And as we come to the end of this inaugural session, now we mean business, we actually start the session. So for all the participants, let me tell you, today I am going to deliver a talk on the introduction of machine learning. And it will be followed up by a hands-on session today. Maybe Rakesh and Neeraj and Soumya, they will be there to teach you the hands-on session. And tomorrow we'll come back with supervised learning. Day after tomorrow, we'll talk about deep learning. And the next day, we'll talk about deep computer vision. And on 5th day, we'll talk about deep signal processing. So that will be the framework of our delivery. And every day, we will have theory sessions as well as hands-on sessions. So all the team members will be involved. Mostly, I'll be involved with the theory, in the theoretical sessions. And the other guys will also be involved in theoretical sessions as well as in the hands-on. So the prerequisites of the hands-on, etc., will be given to you. What are the libraries and like Python, etc., whatever you need to install. All information will be given in today's hands-on session. We expect you all guys to get everything installed, and when you come back, tomorrow, you should be ready. But anyway, we will also show you how to install the libraries to get equipped. Because the good thing is Everything is, whatever we will be discussing will be absolutely freeware. We will be using only free resources, so that nothing, there is no hindrances, there is no question of license, there's no question of anything. So this is absolutely free. So having said this, thank you so much once again. I'll start my session. So I'll just, what I'll do is that I will, let me share the screen. Okay. 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 Machine learning. Okay. Just trying to share the screen. Yes. Okay. And okay. So I'm just checking with you all. Is my okay. Three important things. Am I audible? Am I visible? And is the PPT in full screen mode visible to all of you?
Yes, sir. You are audible, you are visible, and PPT is fully seen by everybody.
Great. So thank you once again, Anilji, for all your efforts. From here on, we carry on the technical session. So my first session is on introduction to machine learning. So students, in this session, what I will try to do here is I will try to explain you what is the basic of machine learning. We'll talk about classification, we'll talk about regression, we'll talk about feature engineering, and okay, we go here. So this is the outline of the presentation. We'll take few examples of machine learning in the real application world, so that you do not get bored, you do not feel monotonous. We'll try to relate the application and try to formulate what is classification and labeling. We'll see what is machine learning. We'll try to understand how machine learn things, the basic paradigm, what is knowledge enhancement in a machine. We'll take some examples of classification and clustering. We'll talk about various methods of machine learning. What are the basic requirements of machine learning? What is feature representation, the dimension of features? We'll talk about issues and concerns, how the model learns. Talk about clustering approaches and classification approaches. We'll talk about some performance measurement matrices like confusion matrix. Then we'll talk about some models, the performance models of the, we'll talk about true, negative, true, positive, etc. And then we'd like to summarize whatever we discussed. So this is the outline of today's presentation. Just to create some interest in you, whatever I said in my inaugural session, I just try to build up something on that, where I say, what are the examples or where you can apply machine learning in today's world? Voice assistants, Google, Facebook, Microsoft, everyone has come up with extraordinary and incredibly accurate systems where voice-enabled commands are available in your mobile phones, computers, laptops. So if not, it was machine learning or deep learning, if the training of machine was not possible, you may not have seen the rise of this kind of voice assistance. I spoke about recommendation system. Big players like Amazon, they use strong recommendation system. Whenever you do a marketing or purchase, they will understand your choices and preferences, and they're going to tell you, recommend you stuffs like what you would like to buy. Character recognition, handwritten character recognition. It seems so, because everybody in this world has a unique handwriting pattern. Everybody writes the alphabet in a different way. So the way a human being looks into a handwritten stuff and understand and interpret the characters. So training the machine for this may not be an easy task at all. So machine learning is very successful and have implemented algorithm for character recognition. Facial recognition and detection is very, very popular these days. Google, Microsoft, almost all big players have got extraordinary, accurate algorithms for face detection system. You must have experience with your mobile phone. Whenever you want to click a camera, whenever you want to click a pic with your camera, you see if there is a face that is, there's a bounding box that comes across the face to detect the face. In drug delivery, the combinations and permutations of molecules and the probable effects on the organs can be actually simulated, and the past experience of learning comes into picture in drug discovery. AlphaGo, it's a gaming software. As I mentioned, I'll tell you about that. That even the computers are in a position to defeat the best of the human beings in the champions of the games like chess and checkers, stock prediction. Almost you can imagine artificial intelligence is playing God. It is predicting future. So there's a strong correlation with the past experience, which you interfere and intervene and try to build up on the information of your past and the features and the reasons responsible for the variation in the stock market that actually is implemented and used to do that. Medical diagnostics is a huge field. Intervention of clinical and medical informatics in screening softwares has become very popular, starting from retinal diseases to cardiac diseases to pulmonary diseases to X-ray screening, MRI screening, CT scan screening. Everything is possible with deep computer vision. We'll see some of the examples in our hands-on session also. But this slide was only to make you understand and develop some kind of interest for you that there is no limit and there's unlimited opportunity of application of machine learning in the real world. This is only some of the popular. Beyond that, I may need 100 slides to show what are the possible applications and what kind of applications have already been done using machine learning in various areas of science and engineering. Okay, so a little bit about the definition. If I ask you what is machine learning, okay, I like this definition. I define machine learning, as per given by Arthur Samuel, 1959. He was a wonderful guy. He said that field of study that gives the computer the ability to learn without being explicitly programmed. So this is a fair definition. This is a good definition where you understand that the computer is programmed. The computer is made intelligent. The computer is made intelligent. In this study, the computer has the ability to learn from its experiences, from the features, without being explicitly programmed. Okay, I'll tell you, 1956. Okay, 1956. Arthur Samuel's checkers program was developed to play with IBM 701. That IBM 701 is hardly a computer. It was more of a mechanical, it was electromechanical controlling device. And in 1962, there was a guy, the self-proclaimed checker master, Norbert Nille, played the game on an IBM 7094 computer, and first time the computer defeated the champion. And that can be considered as a milestone. That can be considered as a milestone for artificial intelligence. As an example of how artificial intelligence had, you can say artificial intelligence had been more powerful than a human mind. And I tell you that this guy, Arthur Samuel, although he developed this in 1959 and 1962 and 63, I told you the reason how, with the involvement of the big data and the powerful massive parallelization tools and the development of the software tools like CNTK models and the PyTorch and TensorFlow model, this came into picture very recently. But still, this definition of Arthur Samuel, the field of study that gives the computers the ability to learn without being explicitly programmed, is still accepted, and most of the textbooks you'll see this definition is used to define machine learning. Okay, we go a little bit ahead now. You know what? In machine learning, talk about natural language processing, computational biology, computer vision, robotics, and many other important areas depend heavily on machine learning. I'll talk about machine learning in the slide. Let's take some examples. We'll take some examples also before we take the examples and actually explain you what is machine learning. Let me tell you what are the types of machine learning. I mean, how a machine learning is different from traditional learning. Okay, in traditional learning, you have a data and you have a program. Okay, so the data, maybe let's talk about, you want to do the square root of a number. You write the program, you give the input, there's a processing unit, there's a computer, and the computer will interpret it and will give you the output. That's a traditional programming in C language or in Java, whatever you have done, you have been doing it for a long time. Now, machine learning is a little different. I split the machine learning into two parts. The first part, I call it as the training model, and the second part, I'll call it the testing part. In the training part, I give, the computer, the processing units, the data, the experience, and the expected out, the labels of the data. For example, I would like to develop a program from which I would like to differentiate between the images of a cat and the images of a dog, and I would like to tell the computer, this is how a cat looks like, and this is how a dog looks like. Now, if you look at from the human perception point of view, a human being can look into a dog from the left, from the right, from the rear side, from the front side, from any side, even a cropped image. Even if the human being looks into the ear of a dog, or the jaws of a dog, or the tail of a dog, or the chest of a dog, a human being can interpret a dog as a dog. Okay. Similarly, a human being can interpret a cat as a cat. How about a machine? How about the machine? You have to train, the learning is actually the training. In technical language, the learning is also called as the training. What I'll be doing is that I'll be taking hundreds and thousands of images of cats and thousands of images of dogs, and I'm going to put it into the machine and label them as cat or a dog. And the processing unit starts reading these labels, understanding the features. There will be features like morphological feature, geometrical feature. There will be, statistical features. There will be many other features. On the basis of that, the computer starts learning how does a cat look like, or how does a dog look like. Now, what I did is that the output was identification of a dog, which I have already given in the input in the learning mode. So the training is going on, and once the model is trained, okay. Once the model is trained, you need to understand that once the model is trained, we'll use this model. We will use this model now to the next level, that is the prediction model or the test model. Now we bring in unseen data. Okay, now let's say we have trained the model with 100 images of cats and 100 images of dogs. Now we bring an unseen and a new data, and I feed them into the trained model, where the computer has learned how a dog looks like or how a cat looks like. And then the trained model is, and the new image, the new test data, when it's fed to the computer, the processing unit, you get the output, and this is how the testing or the prediction is done. So machine learning, remember, any kind of machine learning will have a training part, that is the learning part, and the prediction part, that is the testing part. And they are integrated in such a way that if the learning is good, if the learning is comprehensive, of course, the prediction, the testing part will be more and more accurate, undoubtedly. So this is how the traditional learning is a little different from the machine learning. So machine learning learns from label database and generate a model. And once the model is generated, the test data is actually the unseen or the new test data is fed to the processing unit with the trained model to get the output. I do not know, I'm getting a lot of requests that somebody wants to log in, and my screen is getting absolutely disturbed. I do not know how to control this. Can anybody help me with this, please? My screen is getting popped up. If somebody wants to join, and I'm keeping admitting them, my presentation is getting disturbed. This is not a proper software, I think. How can we stop entry of people right now? Everybody, there's a,
okay, sir.
no, there's a ping, I'm getting disturbed. Can we stop entry of candidates right now? There's a,
Yes, sir. Yes.
Every time there's a, the message popping up. Is it done?
Yes, now fine, sir. Fine.
Okay, thank you. Okay, thank you. I'm sorry, because every time there was a message popping up which was disturbing me. Okay, so great. So we go a little bit ahead from this. Now the next question is, how are things learned? Let's say there's a baby, there's a newborn baby. Just imagine, how does a newborn baby learn? So if you apply the algorithm, how does a newborn baby learns? You may be in a good position to train and make your computer learn as well. The first thing is declarative knowledge, the memorization. It's a boring one, it's an old one, nobody cares. See, when I say memorization, it is limited actually. Let me round up points. First of all, I say the individual facts are accumulated over time. The statements of truth. The statements of truth are recorded into the mind, And however, this memorization of facts is limited by time to observe the facts and the memory to store the facts. Important. If you talk about the time, it's actually the complexity, the speed of the computer in which, let's say you are running a video which is 30 frames per second, so there will be 30 frames in 1 second, and how much do you expect the computer to pick the frame, the objects from the frame and learn? Similarly, a person, for a newborn baby, the brain definitely has a certain amount of limit. Please understand. Just like a memory card has a limit of, let's say, you have got 1 GB or 2 GB, the brain also has a limit. And let's say I ask you to memorize 5,000 names with their roll numbers. It may not be possible because the brain has a limit to memorize, to store the data. This is an old one, a boring method of memorization. If you go to the imperative knowledge, okay, so in imperative knowledge, we are trying to generalize the situation and make a prediction and deduce new facts from the old facts. Experience comes into play, and that seems to be more interesting. That when you bring an experience into play, that seems to be a more smart way and a more interesting way to learn facts. But of course, it is limited by the accuracy of the deduction process. Like when I teach the computer a dog and a cat, if you bring in a dog, and completely a different dog from Africa or the Himalayan mountains, the computer may not be in a position to generalize it to and label it as a dog. So there is an inherent limitation. Essentially, it's a predictive activity and assumes that the past predicts the future. We will see, how this imperative knowledge and generalization model can be improved using those features which are having high discriminatory value, and find other mathematical models to consider only those features which will train the model in such a way that only highest level of discrimination is taken into consideration for training the model. Also, we can infer the useful information from implicit patterns in the data. Nobody can deny that if there is a medical data and if there's a tumor in the brain, let's say talk about an MRI image of a brain, and if there is a tumor, if there's a sign of a tumor, there will be an implicit pattern which a pattern recognition algorithm or any computer vision algorithm can actually take care of that. So the implicit pattern in the data can also reveal information and you can learn things. So these are in general the three, you can say the general components, how things are learned, and we will see how we use them to train computers, also to make artificial intelligence devices. Now, what is the basic paradigm? Okay, let's talk about a spring balance. When you use a spring balance, let's say for 1 kilogram that there is a mass displacement, for 5 kilogram there is a mass displacement, for a 10 kilogram mass there is a displacement on the spring. Now, if you try to relate, let's say for 1 kilogram this is the displacement in the spring, for 2 kilogram this is the displacement in the spring, you may be in a good position to predict what will be the displacement on the spring when you load it with a 1.5 kilogram or 3 kilogram. So you are trying to infer something about the process from the generated the data. Let's talk about the fitting a polynomial curve using a linear regression. That's also a problem. That's how you learn. So this is how it looks like, and that's how we fit it. Now use the learning to make predictions about the previously unseen data. That is the testing set. That's absolutely new data. The model is completely unaware about it. And you are bringing in the data to fit into the model. Of course, as we go ahead, we will see, but the basic paradigm to predict the displacement of other weights, for example, you take a spring balance, you put a 1 kilo, you see the displacement, you put a 2 kilo, you see the displacement, you put a 5 kilo and you see the displacement, and you should be in a position to, new weight, let's say 3 kilo or 4 kilo, you should be in a position to predict. So this is how, the basic paradigm of things are learned. Before I actually go to the types and start discussing about the features, let me tell you a little bit about the types of machine learning. Broadly, I can define machine learning as supervised and unsupervised, and we'll talk about a little bit about the reinforcement learning also. So in supervised learning, it's a task driven. We have to predict something. We talk about classification. So classification is more about defining the labels. Let's say you want to do a definition, you want to separate, I give you an object and ask you whether it's a dog or it is not a dog. So say yes, no problem. Or I tell you this is there is an images of dogs and cats, label them. So you have defined labels, and you will, your machine learning algorithm should be in a position to label a new test object as a cat or a dog. This is how classification works. And in regression, there is no defined labels. It may predict a value. For example, you bring in a lot of features and ask what should be, let's say, what should be the cost of a building in Noida? Okay, so various features will come up. Which sector of Noida? How many bedrooms does it have? Does it has a balcony? Is it in the first floor or is it the 10th floor? Does it have an elevator or doesn't have an elevator? So many, features you bring in, and then finally you say it is 80 lakh rupees. It's a 50 lakh rupees. It's a 35 lakh rupees. So there is no defined labels. There is no defined labels, but it can take a integer value. It can take any continuous value, and this is how a regression problem is solved. So this is about supervised learning. And in supervised learning, what we do is that we take features from the training data, train the model, and then make the model understand in terms of discriminatory behavior of features. And then for the new test data, the model must be in a good position to make classification prediction or regression prediction. So as you know that supervised learning methods like support vector machine, naive Bayes, then maybe your naive Bayes and supervised learning, then naive Bayes, random forest, decision trees are quite popular, and they have been very popular maybe till 2010, 2015. But of course, with the emergence of neural networks and deep learning, they have taken a more, deep learning has become more popular than the supervised learning. What about unsupervised learning? Unsupervised learning is more about clustering data, forming natural groups, finding natural divisions in the feature points to make divisions on their own. We will see. I'll take up example to show you. If I take the features and plot them into a feature point, and if you see the distances between the points are low. For example, in this particular diagram, you can see red process, blue process, and green process. They seem to form nice, a little distribution among them. And I can say they have naturally clustered and naturally grouped among themselves. And this is how unsupervised learning comes into picture, where we do not train the model and we depend on natural division of groups into the feature points to make them natural clusters. We'll talk about that. Next is the reinforcement learning. Reinforcement learning is more about learning from the environment, learning from the mistakes. For example, you want to climb a hill, so you need to make an ascent. So every time you take one step, the algorithm will tell you whether you are ascending, whether you are descending, or whether you are in the same plane or whether the same height. So if you make an ascent, the computer will tell you, okay, go ahead, you start moving and reach towards the the top of the hill. Or if you take a descent, if you go to a wrong gradient, in a negative gradient, the computer will tell you, the algorithm will tell you, you're doing a mistake, you're doing a big mistake, don't do it. So you learn from the mistakes and you take actions accordingly. This is how a reinforcement learning works. So you being, young data scientists, you are beginners. You are beginners in machine learning. So you need to understand that all these three applications of machine learning or types of machine learning finds application in solving different tasks, and they may be a good choice depending upon what task you want to solve with the machine learning. So they are popular in any textbook you study. There will be chapters on supervised learning, unsupervised learning, and reinforcement learning, and we expect you to know that. Now, what we will do, okay, so a little bit, a small introduction, classification versus clustering. So in classification, what we do is, you see, in classification, we are trying to make a decision boundary. You can see the red dots and the black dots. You can see the red dots and maybe the squares, the gray squares. What we're trying to show here is the salary and the age of a person. Let's say the salary is the x-axis and the age is the y-axis. We are plotting those as a feature point. There are two features, the amount, the salary of the person and the age of the person. So when I plotted them in the two-dimensional space, they're the features, okay? Now, there is a nice little line, there's a nice boundary that actually is separating the two divisions, the red ones and the gray ones. I label them as high-risk customers and I label them the other side on the right hand side as the low risk customers. So, this is how I have done a classification model. So if I bring in new points, please understand, if I bring in new unseen data, so whichever position of this graph they lie, if they lie close on the right hand side, on the upper side of the dotted line, I'll call them as low risk customers, or if they lie below the dotted line, I'll call them as high risk customers, because training the data, training the model with the available data, you have already separated your plane, the feature point plane, into two different clusters. Okay, sorry, two different subplanes. And in the clusters, what you're trying to do here is that rather than finding a decision boundary and separating the plane into two classes where you expect the newer points to take up positions above the line or below the line, we try to form some clusters. If you see the image of the clustering, the gray spots and the red spot, the red circles and the gray squares, they tend to form some nice natural clusters of the low risk customers and the high risk customers. So naturally we can say that they form two groups and no supervision is required for clustering. This is a very basic fundamental for you to understand. What I'll do is that now to explain classification and clustering, I'll take an interesting example. I'll take an example from the game of cricket. Okay, so I guess India is a country where cricket is a very popular game. And I'll take a simple example how data is labeled using a learning model. I've been a great cricket fan from the time Kapil Dev lifted the World Cup in 1983. And I'll use a simple problem from the game of cricket to explain you this basic example of machine learning. And I hope it becomes easy for you for learning. What I will do here is that I will label the players in terms of two features. Okay, sorry, in terms of some features, and I'll label them as the rule. I'll label them as a batsman and I'll label them as a bowler. So you must be knowing in a game of cricket, few of the players are batsmen and few of the players are bowlers. So what I do here is, the feature can be a lot of things, but let's use the height and the weight of the person, and let's see if we can get something meaningful, something out of it. Now, for what we are going to do with them is that come up with some kind of characterization of the implicit pattern, and let's say if the height and the weight, okay, the height and the weight has got something to do with the role of the player in the team. And let's see if we can come up with an algorithm that can predict the role of a player with the features that is height and the weight. And that's the paradigm. That's the paradigm, or that's the hypothesis with which we are proceeding. In the set of observations, potentially labeled, potentially not. Think of how do you find a model and how do we use the model to make predictions. Okay, so here we go. So we have labeled the role of the player. We are taking some players from maybe 2012 team. I took some players like Sehwag, Sachin Tendulkar, Gambhir, Virat Kohli, and Dhoni. You can see I have passed on the name. Sehwag 63 and 170. It means that Sehwag is 63 kilograms and 170 centimeters. Sachin is 62 kilograms and 165 centimeters. And similarly, I've taken the bowlers, Zahir Khan, Srishant, Munaf Patel, Harbhajan, and Nehra. I've labeled them in terms of their heights and weights. Please understand, my apologies for you, that please understand heights and weight will definitely not predict the role of a player in a team. There will be many things beyond that. There will be reflexes, there will be batting skills, bowling skills, etc., etc. This example is a simulated data only for making you understand things in a simpler manner. Now I have plotted the point. Now what I did here is that I plotted these points of these guys in terms of weight, that is the x-axis, and the height, that is the y-axis. If I plot this, I get a two-dimensional data. Okay, no big deal. Now what I learned is, are there features that can distinguish one class from another? In an unlabeled case, all I have to see is a set of players if they come close proximity to each other, so that I can make some natural clusters. Now what I need to decide is that how to make these two players similar. The goal is if I can separate into two or more natural clusters. Can I do it? Okay, Similarity is a distance measure. Please understand, similarity is a distance measure. So in this two-dimensional plot where you have taken height as the y-axis and weight as the x-axis, if the points are close enough to each other, maybe we can form a natural cluster among them. So please understand that similarity is a distance measure, and I would like to decide here, how do I take two examples of values of features associated and decide how far or how close are they. In an unlabeled case, the simple way to do is that at least k groups of clusters, in this case there are two groups, how can I decide how the clusters get the best together so that all the examples in one group are close enough to each other and the members of the other groups are far away from each other, reasonably apart. There are many ways to do it. I'll show you one, a very standard one that works basically, and it's as follows. With the goal of separating the samples into distinct natural groups, the similarity between the sample in this feature space will be accessed. I've highlighted that the similarity is a distance measure. Suppose there are k different groups. In this case, k is equal to 2, the batsman and bowler. The role of the player in the team, k is equal to 2. We would like to find whether he's a batsman or whether he is a bowler. So pick k random samples from the training set of the data. Cluster the remaining samples by minimizing the distance between the samples in the same cluster. That's the objective function, the cost function. Put the sample in the group of the closest points and find a new median in the sample data point in each cluster. Okay, repeat this iteration and keep repeating this iteration till there is no change is observed. When there is no change observed, we understand that the natural clusters has been formed. The idea, let me summarize what I'm trying to say. The idea is that distance between the elements of the same cluster will be small. So we can say clustering depends on the similarity distance. So that's how we are trying to make some natural clusters. Now what we do here is that, what if I try to divide it in terms of height? So here it is. What we have done for the cricket players is that we are doing it on the basis of height. We did it for the weight. Now we're trying to do it for height. There is a naturally dividing line. It makes some kind of sense. Okay. So this 5 are clustered below the axis and some 5 are clustered above the axis, top of the axis. And on the basis of this decision boundary, we're trying to make them, whether they are some batsmen or whether they're bowlers. Now, if I do it in terms of your weight, it's not as clean. It is not as clean because if I make this is the best thing I can do, and this line, the right on the side, you have only 3 points, and all of this are on the left hand side. So this is not neat. This is not clean. So this is the best. What my algorithm came up with, the best dividing line here means that 3 of them are clustered on one group and others are on the other side of the group. This is not very clean. So let's try to look into the issue to find a better cluster. What if I use both height and weight? In the previous case, initially I used weight. Now I used height. Now I'm trying to use both the features to classify them as clusters. Those 5 are grouped as one cluster and the remaining are grouped as the other cluster. This seems to make more sense when I use both these 2 features to make them natural clusters. So what you need to understand here is that this naturally dividing also, there is a nice naturally dividing line through here, and the fact that gives me a classifier, because there is a natural dividing line that comes into picture. This line will be equidistant line from the center of the 2 clusters, meaning any point on this line is the same distance from the center of that group to the center of the other group. The idea is simple. Here I want to find the elements near to each other to form a cluster and far away from the other members of the group. So a very basic example to make you understand this. And now suppose I knew the labels of the players. You can see now that the line is one label, the line is labeled 1, the top one, the batsman, and the line above it as the bowlers. The basic idea is here to get, is a label data in the feature space Now what I'm going to do is taking the advantage of this label sets. Let's see how I can divide this into groups. And maybe from the label data, I would like to find a subsurface that naturally divided this surface. And now subsurface is a fancy word. Don't get bogged down with that. So it is a two-dimensional space. I'll ask, what's the best line if I can get a single line? What separates all the examples of one label to the examples of the other label? Is that really possible? Is that really possible? So let's summarize. Finding classifier surfaces, given the label groups in the feature space is desirable to determine if the surface which has capable of separating the data points into that group. Remember, subject to constraints on complexity of the surface. What I showed here was a pretty simple surface in terms of heights and weights. The real life problems will be much more complex distribution of points. I'll show you this. I'll take up more examples. In this example of these 2D feature points were available. So line or connected or set of lines or segment that separates a point into groups was available. And when the data points in the label groups overlaps, okay, then there is a good need that arises for trading off the false positive and the false negative. I introduced something called as false positive. Now, you want to label a batsman as a batsman, or the chances a batsman is labeled as a bowler is labeled as a bowler, and a bowler is labeled as a batsman. So true positive, true negative, false positive, false negative. So 4 possibilities comes into picture, and you need to take care. How do you eliminate the false positive and the true negatives to ensure that the acceptance ratio and the rejection ratio is as accurate as possible? It may be easy in some cases, and it may not be so easy in some cases because other cases may be complex. So, in some cases, as some points of the label data of different groups may be close to each other, that also may initiate a new understanding of a new undesired thing, that may come into picture is called the overfitting. I really want to discourage a really complicated surface to separate these labeled data points. Otherwise, my machine may start memorizing stuff implicitly in a way where it leads into undesired grouping of labels and get into something called an overfitting problem. I'll tell you about overfitting problem at the end of this, maybe a little bit later. And what we have to tolerate here is that as a data scientist, as a machine learning scientist, you have to make a conscious decision. I'll show you examples. How do you tolerate the incorrect things? The false positive or the true negative, the acceptance or the rejection, a dog labeled as a cat or a cat labeled as a dog. To what extent you tolerate and optimize your algorithm. And you can see in this case, the best fitting line in the previous slide was what we got it. Okay. So as a data scientist, as you get more and more experience, you get more and more understanding of bringing in linearity or non-linearity, in your two-dimensional surface to separate the points in your training model. Now we bring in the test data. I bring in 2 new players, Yuvraj and Shami. Yuvraj is 72, 167, and Shami is 75 and 170. Of course, this data is simulated data. Please understand they're not correct data. When I plot them, Yuvraj and Shami as the black points, I see they get somewhere very close to their, the 2 label database or the clusters of the natural clusters. And I can somehow naturally, once again, make those clusters, and Yuvraj gets into the batsman group, and the Shami goes into the bowler group, which means the naturally dividing line was good enough to predict unseen new data. Having said this, what are the paradigms of machine learning methods? We will see some examples. Learn models on unlabeled data by clustering, okay, the data into nearby groups, or resulting clusters into the label database of the clusters that can assign labels to new data. Learn models that separates the data points with similar label data to the another group. It may be possible to perfectly separate the data point into distinct groups without overfitting. But of course, having doing this, underfitting may also be a problem we will see. Hence, the decisions with respect to trade-off are undertaken. The false positives and the false negatives has to be taken into consideration. That's important. And the labels can be assigned to the new test data without using the resulting classifiers. And all machine learnings require a few things. So we try to summarize here. What are the important things machine learning method require? Number one, choosing the training data for the evaluation method, representation of features. This is very important. Here, what happened is that I happen to choose the weight of the height and weight of the cricket players and not sure if they really work. There may be many other skills important for a cricket player. You know, maybe I'll be better off picking physical fitness of a player. I don't know. Maybe his muscle reflex, maybe his timing, maybe his, you know, his athleticism, there may be many other factors, and we do not know. So as a data scientist, it's your, you know, it's your conscious effort, it's your, you know, experience that comes into play to pick the best features, to make the feature points, to plot them into the data space where you can find the natural clusters or classification levels. Now, the distance matrix from the feature vector, so we'll talk about it. We'll talk about the Minkowski's matrix, where you'll see what kind of distance measurement we do. The loss function and the constraints. We'll talk about loss function. The loss function is when the network, the model predicts something which was not desired or labeled. And how do you train your artificial intelligence classifier to tell you've done a mistake, you know, mend it. Optimization methods for learning model. What is the best optimization model? What is the best thing that you can get? So these points have to be considered. In the next few slides, you will see, we'll talk about that. And feature representation or feature engineering is the strength of a data scientist. I will take an example. I'll take an example of an animal. So I'll take an example of this. My problem here is I would like to label reptiles. I would like to label reptiles. But before I go, let me talk a little bit about the feature representation, because the core strength of any data scientist is how do you actually represent features to train a model. There was a guy called George, you know, Box. He was George Box, you know, 1919 to 2013. He was a British statistician who worked in areas of quality control, time series analysis, design of experiments. He was into Bayesian stuff, etc. He has been, you know, one of the greatest statistical minds in 20th century, and he gave a statement that all models are wrong, but some may be useful. So, you know, that makes everything clear to you. So how much ever experienced data scientist you are, how much ever experience you bring in with handling data science problems, still the model that you predict may not be correct always. You live with some kind of probability. You have to live with some kind of probability, because the entire feature engineering depends on a probability model. And this guy, George Box, who is a renowned statistician, he says it is absolutely wrong, but it can be useful. So what we are going to explore here is that how you can bring this usefulness into picture in doing feature representation. Now, feature engineering is an important, you know, it's very important. It brings out the pieces of information from the data to understand a problem. They are fed into a machine learning algorithm to help it learn, especially in supervised learning. The choice of the features and dimensional reduction of the features is the biggest challenge a data scientist can ever come across. We represent data points by feature vector that will facilitate the generalization. Features don't actually capture what you want. The cricket player analysis that we spoke just now may not be correct. You know, so you as a designer, you need to decide what are the best features that may result into the best possible learning. That may, you know, for example, you know, let's talk about how will I predict the grade of your computer science course this semester. You know, let's say I make a feature model and I would like to do artificial intelligence analysis to understand what will be your final grade of your machine learning course of this semester. Okay, so maybe I'll take your programming skills into picture, sounds good. Or maybe I'll take your previous performances, like what was your previous CGPA, SGPA of your previous semesters. They may be also good enough. I mean, they may be a good indicator. Maybe these features like GPA, CGPA may be good. On the other hand, I do not believe in astrology. You know, maybe your birth of your month, you're born in January or February. That has nothing to do with the grade that you're going to get. Or maybe the color of your eye. Maybe I say your eye is brown or eye is black. That has got nothing to do with your grade. Maybe your height and weight. That has got nothing to do with your grade. Maybe the color of your skin. That has got nothing to do with your grade. don't worry, our university, Dr. APJ Abdul Kalam Technical University, won't make a simulation to decide your grades. We will do it in practical. Don't worry about that part. But if you feed the computer with unnecessary data, let's say the problem is what will be your grade this semester. I'm making a prediction. Your programming skills, your previous performances may be good enough, but the color of your eye or the birth of your month may lead into overfitting problems. So what happens, if you feed data which are irrelevant and non-discriminatory in nature, the computer program will make its own cluster, the computer program will make its own labeling method, and you get into some kind of undesired experiences and undesired models, and you lead into irrelevant features that lead to overfitting. So we need to avoid and eliminate overfitting and choose only those features with proper dimensions to ensure that the model is perfectly trained. No more cricket players, no more cricket. We go to animals. Let's have a little bit of difference. I have a viper. Okay, it's a poisonous snake. I have a cobra. It's a poisonous snake. I have an emerald tree boas. This is a non-poisonous snake and it does not lay eggs. I have purposely chosen that, I have to show you how, the feature engineering matters. I have a fish, a roe fish. I have an alligator, a crocodile. I have a python, and I have a golden poison frog. So these are the set of animals on the basis of which I will go for some feature engineering. Now, my problem is I would like to make an artificially intelligent classifier to label a reptile. I would like to find the features of a reptile. I would like the computer to understand what is a reptile or what are the different features that represent a reptile. Okay. So I bring in 5 features. I say, if it is egg-laying, if it has got scales, if it is poisonous, if it is cold-blooded, if it has 0 legs, it's a reptile. So I marked it as true. I bring in the first animal, that is the viper. The viper is egg-laying, true. Scales, true. Poisonous, true. Cold-blooded, true. Legs, 0. Reptile, yes, true. I bring in the next one. I bring in the cobra. Egg-laying, yes. Scales, yes. Poisonous, yes. Cold-blooded, yes. Legs, 0. Reptile, yes. The model I made perfectly fits in the viper, and it perfectly fits in the cobra also. No problem. We are very happy. We have found the model. Now I can say, okay, great. Now I have found the features to label a reptile. So I'll say if it's egg-laying, if it has scales, it is poisonous, cold-blooded, and 0 legs, that's reptile. Great. It fits in for viper. It fits in for the cobra also. Now, there is a problem. I bring in the emerald tree boas. It's egg-laying? No, it does not lay eggs. False. Scales? Yes. Poisonous? No, it's a non-poisonous, it's a non-venomous snake. Cold-blooded? Yes. Legs? 0. Reptile? Yes. Oh, you have a problem. That emerald is a reptile, but doesn't fit into the developed model. It's not satisfying all the features. There is a problem. The model that you have developed and the viper and the cobra, which perfectly fit into this model, emerald is no longer fitting into that. What do? 2 features, it has failed. It's not egg-laying, it's not poisonous. So what I do here is I reduce the features. I remove the egg-laying part. I remove the poisonous part. I only live with scales, cold-blooded, and no legs, 0 legs. So I say, if it has scales, if it is cold-blooded, if it has no legs, it's a reptile. Look into the model and the following features, the only 3. So 3 features is defining reptile at this particular stage. Let's go ahead a little bit. We throw in the alligator. Egg-laying, true. Scales, true. Poisonous, false. Cold-blooded, true. Legs, oh, the crocodile has got 4 legs. Reptile, yes, we have a problem. The crocodile is a reptile, but it has got 4 legs. So how do we fit in, or how do we, filter our model? How do we refine our features? How do we redefine our features? Okay, what we do? Okay, we say scales, yes. Cold-blooded, yes. Now for legs, I simply increase the dimension, and I say that if it has got 0 to 4 legs. So reptile has the crocodile has got 4 legs. Cobra has got 0 legs. I'm increasing the limit of legs. So if I say now I have redefined my model that if it has got scales, if it is cold-blooded, and if it has got 0 to 4 legs, it's a reptile. I have redefined the model. Let's go ahead a little bit. I bring in the golden poison frog. Egg-laying, true. Scales, false. Poisonous, true. Cold-blooded, false. Legs, 4. Reptile, no. Now, once again, you have a problem. It fits in to the model of reptile, but it's not a reptile, it's an amphibian. Now we bring in the rohu. Egg-laying, yes. Scales, yes. Poisonous, no. Cold-blooded, yes. Legs, 0. Reptile, no. So the features of rohu meet the features of the current model, but rohu is not a reptile. It's a false positive. You have accepted something which was not a reptile. Okay, we bring in the python. You see, the features of rohu or python are exactly same. Okay, but the labels are different. So what I'm trying to only explain you here is that there is no easy way to add or remove features to help to classify them correctly. So labeling them as a reptile, you see, you are leading into true negatives. Okay, a golden frog, which was not a reptile, is labeled as a reptile, or a python, sorry, a fish, a rohu, which was not a reptile, but it fits into the model, or something like a crocodile, which is actually a reptile, do not fit into the problem. No, it's never easy to find proper features and define the class or the labels in terms of features which perfectly fit into the model. So no easy way to remove or add features that can help to classify correctly. So what do we do? One method may be we need to measure the distances between the features. Here comes feature engineering into play. Can we decide which features is to be included in the model and which is not to be included in the model? As using all the features merely add to the noise in the learning process. They're not discriminated at all. They're not informative. Rather, it's making the model more confusing and leading to overfitting problems. The second step is to define the distance. It will help to measure the distance between the training data points and the new instances. To make a clear-cut understanding of the feature map, to either to separate it for classification or to cluster into natural groups. To decide how to weigh the relative importance of different dimensions in feature vector, which impacts the definition of the distance. If you cannot do these 3 things properly, the feature engineering will be impacted and the model that you're going to train may not be accurate and robust to take into consideration for new and unseen data. So how do we measure the distance between the animals that we consider? Let's try to convert these features into vectors. In this considered example, each animal consists 4 binary features. Okay, egg-laying, it's a binary decision, yes, no. Scales, yes, no. Poisonous, yes, no. Cold-blooded, yes, no. But it had one integer feature, the legs. It can be a 0 to 4. So legs are not a binary feature, and all the other features, egg-laying, scales, poisonous, and cold-blooded, are binary features. So let's try to make the feature vectors. One way to learn is to separate the reptiles from the non-reptiles, to measure the distance between this pair of data points. Oh, okay, to cluster nearby examples to form a cluster and unlabeled data, or to find a classified surface in the feature space that optimally separates the different groups of data points from the other groups. Okay, so what we try to do here is that we try to generate a feature vector. For example, the Viper. We are converting the given database into the set of feature vectors, the Viper, that is your 1, 1, 1, 0. It means egg laying, yes, so a 1. Scales, yes, so a 1. Poisonous, true, so a 1. Cold-blooded, true, so a 1. And number of legs, 0. So you bring in a 0 here. Same for emerald tree boas, you can understand. Egg laying, no. So you bring a 0. Scales, true, so there's a 1. Poisonous, false, so it's a 0. Cold-blooded, true, so you have a 1. A number of legs, 0, so it's 0. For the golden poison frog, egg laying, true, 1. Scales, false, 0. Poisonous, true, 1. Cold-blooded, false, so it's 0. And legs is 4. It's an amphibian. So this is how we have converted the given data set into a set of feature vectors. Okay. So once we have converted these feature vectors, now these vectors can be used to measure the distance between them. I introduce you to the Minkowski's matrix. Okay. Let me tell you, this is the definition of Minkowski's difference. So distance x1, x2, comma p, k is equal to 1 to ln. Ln is the length of the vector. So the absolute value of x1k minus x2k to the power of p, and it's a whole square root of p. There's 1 to the power of 1 by p. If you put p is equal to 1, you get the Manhattan distance. If you put p is equal to 2, you get the Euclidean distance. Now, you know, there are more complex distance measurement like Hausdorff distances, etc. But because this is an introductory lecture, we will keep the discussion limited to Manhattan distance and Euclidean distance. Okay. Let me define you something like this. Now, I ask you in this particular situation, is the circle closer to the cross or the circle is closer to the star? Okay, so typically Euclidean distance is used and Manhattan distance is appropriate if the different dimensions are not if different dimensions are not comparable. Manhattan distance are typically the distance you can walk along using the avenues and streets. For example, okay, let's see here. My question here is, the circle is closer to the cross or is it closer to the star? Let's see. So if I want to measure it to the star, okay, and this is the cross. Now for the Euclidean distance, you can see, okay, let's go. So this is the Manhattan distance, 1, 2, 3, 1, 2, 3, and 4. So the Manhattan distance between the circle and the cross is 4. Okay, let's see the star. So it's 1, it's 2, and 3. The Manhattan distance between the circle and the star is 3. Now, if you talk about the Euclidean, if you look at the Euclidean distance, it's pretty simple. The Euclidean distance between the circle and the star is 3. There are 3 units. I think you can see there are 3 units. So you can see, so 1, 2, and 3. And to measure the distance between the circle and the cross, you have to take it as 2 square plus 2 square under root. That will return you 2.8. Okay. Now for the Viper, you have the feature vector as 1, 1, 1, 0. For the emerald tree boys, you have got 0, 1, 0, 1, 0. And for the golden poison frog, you have got 1, 0, 1, 0, 4. Now let's put these feature vectors into the measurement of distances. Let's see how it goes. Okay. Okay. So we are trying to calculate the Euclidean distance between these two animals. Viper, 1, 1, 1, 1, 0. Emerald boss, 0, 1, 0, 1, 0. And golden poison frog, 1, 0, 1, 0, 4. Measure the distance, okay, between the emerald tree boss and the Viper. You see how much does it comes out? It comes out as 1.414. That is under square root of 2. So it'll be what? 1 minus 0 plus whole square plus 1 minus 1 whole square plus 1 minus 0 whole square plus 1 minus 1 whole square plus 0 whole square, the under root. So it will come out as 2 square. This is 1.414, the equivalent distance between these two vectors. So what you can see is that both the snakes are reasonably close to each other, while the golden poison frog is fairly distant away from each other because it has got a dimension associated with it. Okay, there's a dimension associated because there are 4 legs. There are 4 legs for this frog. Now I bring in the alligator. The feature vector for this alligator will be 1, 1, 0, 1, 4 because it has got, once again, 4 legs. Let's try to see how the distance will look like. So for the crocodile, if you see, the 2 snakes are closer, but the crocodile is closer to the golden poison frog. Okay, the crocodile differs from frog in 3 features and from the boas in only 2 features, but still you see the crocodile is closer to the frog than the boas. Okay, so other features are binary, that is true or false, while the legs has a dimension of 4 and disproportionately consists from 0 to 4. So here comes the Manhattan distance into picture. There is a dimensionally, there's a variation in the dimension, and the Manhattan distance may be a good choice of distance to to incorporate in this kind of distance measurement. So here, here what I do, I consider a binary feature. Okay, what I do here is that I eliminate the legs as 0 to 4, and I put it as 0 to, I put it as true and false. If it has legs, I'll put it as 0. If it has no if it has legs, I'll put it as 1. If it has no legs, I put it as 0. So the legs at this moment are no longer a 4-dimension vector or a feature, but then it's only a binary feature, yes or no, leg or no leg. If I make the leg as a binary feature, all of a sudden you see, you see that the crocodile is closer to the snake than the dart frog, than the golden poison frog, and it makes more sense. It makes really more sense because the crocodile has moved towards that, and hence I can tell you that the feature engineering really matters. The feature engineering really matters. The moment you reduce the dimension of the legs from 4 and made it a binary feature, leg or no leg, yes or no, true or false, the crocodile has moved closer to the frog where the snakes are still closer to each other. So feature engineering definitely matters. Here comes the experience and the expertise of a data scientist. How do you choose features to train your model in making a nicely optimized and accurate artificial intelligence classifier? The issues of concerns where a model learns. This is also a tricky part. I expect you to understand this, okay? So learned model depends on the following considerations to measure the distance between the data points. Important. Choice of right set of feature vectors. We're trying to summarize what we studied. Constraints of the complexity of the model. Specified number of clusters in case of unclustered data. Complexity of the surface that is separating the surface. You want to avoid the overfitting problem. You do not want to get into too much complex problem where each data set starts behaving as its own cluster in the complex separating surface. That's completely undesirable. Now, if you talk about the clustering approaches, suppose there were k different groups in our trained data, but we do not know the number of labels. For example, here k is equal to 2. You pick k samples in random from the training set of data, minimize the distance between the remaining samples from the selected data points, and find a median and repeat it till there is no change observed. We mentioned that. And the issues are how do you find the best number of clusters and how do you select the best features from the distance matrix. We talked about the height and the width. And maybe, what happens all of a sudden is if you bring in a third cluster naturally, you have a third cluster. So it depends. As a data scientist, how are you labeling the clusters or how are you forming those natural groups to label them into clusters? So classification approaches also, there are challenges. What I will do right now is that to explain you a classification approach, I'll take an interesting example. Okay, we want to find boundaries and feature space that separate the different classes of the labeled data points. We look for simple surfaces, maybe the best line of the plane that separate the classes. Or we look for more complex surfaces subject to constraints that separate the classes. Or here what we do, let's use a voting schemes, find the key, maybe training examples, use the majority of the vote to select the label. And the issues will be how do you avoid the overfitting to data, how do you measure the performances, and how do you select the best features. To explain this, I'll take an example. Of course, this is a simulated example. Don't worry too much. Don't worry too much about. Don't worry too much about this. This example, because this is a simulated data. What I'm trying to explain here is what I'll be trying to. Can we have a what I'll do is that okay, we will take a maybe a 2 or 3 minute break, and I'll come back after 2 to 3 minutes time, and I'll conclude this discussion. Maybe a break for 3 minutes. Okay. Okay, so we are back. So I think is the audio video is the audio and video visible and audible? Am I audible and am I visible? Am I visible?
Yes, sir.
Okay. Can somebody stop the entry of this participants? Somebody is, it's getting popped up. It's not well managed actually. I'm not happy with all this thing. Anyway, so the classification approaches we spoke about. Now, what we'll do here is that this is my last example where I'd like to explain something to you. Okay. So what I'm trying to do here, this is a simulated experience. This is a simulated experiment. I'm trying to look into the voter preferences. I'm trying to look into the voter preferences. The red one is the BJP voter, and the red circles are BJP voters, and the blue triangles are the Congress voters. I've taken the x-axis from the distance from Lucknow, and the y-axis is the age. So I'm just trying to simulate and understand. I'm trying to find a distribution if I can actually group the voter preference. If I can group the voter preference something in terms of distances and ages from a particular city. It may look, absolutely, it's a simulated data. So we do not know whether age or distance from Lucknow has anything to do with the voter preference. But just for your explanation and how to optimize things and how do you live with the different false positive and false negative, I've taken up this example. So this is what we have. Attempt to minimize the error on the training data. Similar to fitting the curve to a data, you would like to evaluate on training data. The voter preference by the age and distance from Lucknow. We randomly divided into the data into training and the test set. Okay. The red are the BJP voters and the blue are the Congress voters. I'm trying to find some kind of a boundary. Now, if you consider the solid line, you see there are no false positive on the right hand side of the solid line because you have labeled all the Congress voters correctly. You have separated them. And if you look into the dotted line, you live with one false positive because there's one red spot. There's one red spot on the right side of the dotted line, and it means that in the training model you have one discrepancy. The choice of a classification or interfacing boundary to make the two separate subsurfaces in a feature map, in a feature plot, is challenging. Let's say how we go about it. So here you see for the solid line and for the dashed line, what we have here is in the solid line we have got true positives, 12 true positives and 6 true negatives. It means 12 of the Congress voters are labeled properly and 6 of the Congress voters are labeled mistaken in a wrong manner, and 0 false positives and 11 false negatives. So you can see here none of the BJP voter is on the right hand side of the solid line, which means that it has 0 true false positive. Okay, but it has got 11 that is your false negatives. Means all Congress are Congress voters are properly labeled as Congress voters. Now, if you look into the dashed line, you have 11 true positives, which means 11 Congress voters are properly labeled and 6 of them are. I'm sorry, this should have been 7. There's a mistake. So 7 of them are mistaken. And in negative, you can see in the dashed line, one BJP voter is actually coming in the right hand side. So there is 1 true negative, and there are 11 true. There is 1 false negative and 11 false. False negatives. 1 false positive and 1 false positive and 11 false negative. So
this is actually indicating what is the acceptance and rejection. For example, how many Congress voters you are accepting and how many Congress voters, non-Congress voters you are rejecting, or how many BJP voters you are accepting and how many non-BJP voters you are rejecting. So it is not only about the accepting, the correctly labeling the data, is also about rejecting the wrong data. Okay, because if I say I accept everything, so of course all the Congress data will come, but at the same time you've accepted wrong data also. So it is not only about the acceptance rate, but also the rejection rate that comes into picture that has to be taken care of in training the model in a machine learning classifier. So I told you the definitions of true positive, number of BJP voter preference samples that have been classified correctly. With a solid line, it's 12, and with the dashed line it's 11. The false negative, the number of Congress voter preferences samples that were classified by the BJP voter. Okay, so false negative, you can see it was 0 for the solid line and 1 for the dashed line. The true negative was the number of Congress voter preference samples that have been classified correctly. That is 6 for your solid line and 7 for your dashed line. It's a mistake in the table. You please read it as 7. And for false positives, the number of BJP voter samples that has been classified as Congress voter. So it was false positive was 0 for the solid line. It was 1 for the dashed line. So the question is, we define something called as accuracy. So accuracy not only depends on the correct acceptance, but also depends on the correct rejection also. Okay, so accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So in this for the solid case, if you put the values for the solid line, you get an accuracy of around 0.85, and for the dashed line, you get an accuracy around 0.88. So that's what you live with. Okay, you have to live with some false positive and some true negatives when you are making the decision boundaries in training a model. We go a little bit more complex. We go for a voter preference, and we do not keep. So in this particular cases, we just tried for a linear separating model. So instead of linear, we try to bring in a non-linear model. We'll study more about non-linearity in your deep neural networks, because deep neural network, the activation function always introduces a non-linearity to to take care of the complex surfaces. So if I bring in a non-linear separating surface, which you can see in this slide, you get a better separation of these two voter preferences. So in this particular case, true positive is 12, false positive is 4, true negative is 12, and false negative is 0. So the accuracy is 24 by 26. It goes up to 92%. So also what you need to understand that linear kernels, linear separation kernels or linear separation lines may not be always a good choice in complex distribution of data, which is evident from this particular simulated data, that bringing in the non-linearity in the separation of these two voter preferences yielded up to an accuracy of 92%. Okay, some more statistical measures that you need to understand, because whenever you solve a problem as a data scientist, you learn, you make a learning model, then you do the testing, and then actually you bring in these measures to the performance measuring coefficients like positive predicted value, that is true positive divided by true positive plus false positive. For the solid line was 0.48, for the solid dash line was 0.67, and for the complex model was 0.61. You can calculate for yourself, and you can see how this true positive predicted value comes in. One can also use the following parameters like sensitivity and specificity. Specificity is correctly accepted, and specificity is correctly rejected. So it's not only that you correctly accept the BJP voters, but you have to reject the non-BJP voters also. So that is the job of a classifier, that it should not only accept the correct data, but also should reject the false data, that means the wrong data. Because if I make sensitivity is equal to 1, I mean label all, the specificity becomes 0. So you accepted everything. Okay, and the vice versa. If I make specificity as 1, I mean reject everything, the sensitivity becomes 0. So that actually makes no much sense. To operate on that, you will study more about receiver operating curve. We call it as ROC, where the false positive and the true negatives are marked as the x-axis and the y-axis, And the area under those kind of curves actually is an indication about the performance of the AI classifiers which you'll study. You'll know that whenever you present a data or a performance analysis of a training model, you need to present an ROC, the ROC curve, that is a receiver operating curve, where the trade-off between the acceptance and the rejection, the percentage that is correctly found and the percentage that is correctly rejected is traded off, and we get the area under that curve, and that is an important parameter to understand the performance and the accuracy and optimization of a trained learning model. Okay, so whatever we studied today, we would like to summarize. Okay, so machine learning method provides a way of building models from data sets. We have got imperative learning and generalized learning, learn from the past, like supervised learning. You'll study more about supervised learning in the next lecture. And in supervised learning, we use label data and create the classifiers that optimally separate the data into known classes. In unsupervised learning, we go for clustering, tries to find and infer the latent relationship between the training data example by clustering into nearby groups, find some natural clusters, reduce the distance between the points, and make some natural groups. We also seen the choice of features influence the results of the data points grouping. That was important. We saw how the moment we make the legs from 0 to 4 into a binary feature between true and false, the snakes labeled close and the alligator started moving towards, the alligator also moved towards the snake. So the feature engineering is indeed a very important, expertise of the data scientists, which are going to learn and use. The choice of the distance metrics, as we saw, Manhattan distance and Euclidean distances between two examples also influence the results. Okay, so when you decide the features, the dimensions of the features, and choose the proper matrices, the distance metric, for example, you're going to choose, a Euclidean distance, or do you use a Manhattan distance or a Hausdorff distance, that'll actually also influence the results. For a data scientist, the machine learning method, the experience-based learning, the training model, the elimination of overfitting and unfitting, making it the most optimized, bringing non-linearity to cluster them or classify them into proper subsets, choice of features, and finally the matrix measurement to find the closeness between the similar groups and distance apart for different groups. That actually is the complete thing that a data scientist or an AI professional should learn. This was all about the introduction to machine learning. You studied all these things, and now you know how labeling data and feature engineering is worked. So that's all I have at the introduction. We will have hands-on session after this, and I can take a few questions from you because this is the introductory lecture. You may have a few questions. I close my PPT, and maybe we can have a few questions from the students and the participants. We are open for some questions. If you have a question, you can ask me. We are open for some questions. Anyone has a question? Can you hear me? Can you see me? If you have a question, you can ask me. Somebody is putting a question in the chat that how machine learning helps for solving real-time problem. I think Dheeraj is asking this question, but you know what? We will talk about it in real-life problem. I mentioned as in my previous cases, in my previous cases, that there are many things, in medical informatics, in prediction models, in recommendation systems. You can always put a learning a training model to learn on the basis of the previous experience, and we will show you some examples in the hands-on session. Somebody's asking, I have a question, I'm unable to unmute. Okay, how to decide the value of K in clustering if you do not know in advance? So right in the chat box, it's saying the first. Okay, so let me tell you, for clustering, the value of K, as I showed you, you label them and find the median, and then repeat the process again and again till you do not see a change occurring And then you say that the natural clusters have been formed. Next question is, how does machine learning help to overcome the pandemic corona situation? We actually, I'll show you a slide. The X-rays, the X-rays of the chest congestion. We have worked on that. Maybe if I get some time, I'll show you in one of my presentations that the chest congestion. You must know the RT-PCR method is used to check the COVID infection. But me, with a group from European scientists and guys from KGMU, that your medical university, we formed a deep learning-based model where from the chest X-ray image, we are able to predict whether it's a healthy guy, whether it's a pneumonia, whether it's a viral pneumonia, whether it's a bacterial pneumonia, or whether it was a COVID infection. So the model is ready. The prototype is under clinical trial in KGMU. So we can use those medical images to predict or screen COVID patients. What is the difference between machine learning and deep learning? So to answer this, in deep learning, you eliminate the feature engineering and make the process completely automatic. In deep learning, you do not do feature engineering, you do not choose handcrafted features, and your model automatically scales up your features, scales up the features at different scales and trains the deep neural network. So you do not do feature engineering in deep neural network. Once the model is trained, then if some random data is provided to analyze and predict which model would be better. No, this question I'm not able to understand. Which model will be better means we have to do the experiment. Let's say you use a support vector machine or a naive Bayes or you use a random forest. You have to do the experiments and find out for yourself which is giving the best accuracy. The performance parameters I've already mentioned. What are your thoughts on AI overpowering humanity in far future? So you cannot. This is nothing to worry that humanity will be controlled by computers. Don't worry on that part because these computers do not have emotions, and don't worry on that part because anyway you cannot control human being. Maybe the efficiency of delivering a task will be as far as human being or maybe faster than a human being. But of course, AI cannot control human being. Rest assured on that part. AI versus soft computing, it means no sense actually. Soft computing is any other question? Okay, so what I will do here is that we will close this session here. Maybe 5 minutes from now, or maybe 10 minutes from now, we will have the next session and maybe some basics hands-on. We will explain you about it. So we will close the. You can stay tuned. 10 minutes from now, we come back and maybe we'll tell you a little bit about the practical part of it. Okay, thank you so much for your attention. Stay tuned. We will resume the session in 10 minutes from now.
Hello.
Good morning, everyone. Am I audible?
Yes, you are audible.
I will take the hands-on session. I think so. My browser is visible. I think so. Google Chrome. In the first session, we have learned about the machine learning, but how you can apply the machine learning algorithm in real-time systems or real-world systems. Then you have to make some, means you have to go through the programming, means you have to make some program or something, implement these things, means you have to prepare your framework where you can implement these types of machine learning and deep learning theorems. So for that, we have chosen two platforms. One is the Google Colab, and second is the Anaconda framework. So I hope most of this is a hands-on session. So I hope most of the candidates can have their laptops in front of them so that they can install some library or means so they prepare their framework, because in upcoming days you have to you will have programming in those frameworks. So I will tell what is the need of these systems and what are the advantage and how we can implement step by step. So first thing, one thing, if you are you are trying to install the things, one is the Anaconda framework. Anaconda framework, that means the ID means when you want to program, means you want to program offline, in offline mode, you can say even this system, then you can use the Anaconda framework. And second platform in Google Colab, that means you have you are working on a programming in online platform. I will tell, but first you have to install. You have to first you have to make a Google search, means Anaconda 2019.10. You have to search Anaconda 2019.10 in Google. I'm repeating, you have to search Anaconda 2019.10. Then when you Google, then there is one link, repo.anaconda.com, that show archive versions. Once you click, it will show different versions. There are 2020 versions also and 2019 version also. What is the thing? Means I am telling to install 2019.10 still when the original upgrade version is already there. Means when you install this framework 20 means the versions according to your system, then there may be some because we are using the system and some systems are not supporting that. Means it will if you download that software and you try to install, it will take very long time, and sometimes it take an infinity time, means it not install. So I'm suggesting to install Anaconda 3. There are version Anaconda 2 and Anaconda 3 and 2019.10. Then you have to choose which system you are using. If you are using the Mac OS, then you can use Mac OS system. You are using the Windows 64-bit system, then you can use this system. So what I prefer to use Anaconda 3 2019.10. I'm highlighting this. See, Anaconda 3 2019.10 version for Windows 8 into 86 into 64-bit system. It is a 461.5 MB system. It is launched on the 15 October 2019. This is the version. It's Anaconda 3 2019.10. This is the version. While I will tell all the things in between, the event put this as in your download section. It's Anaconda 3 2019.10 Windows 86 64. This is the framework. We will talk about this later, means once you have a downloaded system, because network connectivity, but this is the system. And we have downloaded this only because there is some error issue in the 2020 version. So please install this version. There is no such much difference between those two versions. Second thing is we have to choose Google Colab. When we have to make programming, then you have to make your Google account login. You can sign in from your Gmail account. Once you sign in your Gmail account, then open Colab. Instead of, because I have already worked on that, I will show you URL. Means you can already simple search Colab, simple COLAB. COLAB. This is the Google Colab platform. Google Colab. So open Google Colab. If you have made, you have already made the program, then it will show the list. Otherwise, you can click New Notebook. Click on New Notebook. It will take some time. Then it will open the notebook. Means this is the platform where we will do programming. One thing, what is the advantage of Google Colab? Means it is developed by Google that supports GPUs, that Google provide the GPUs for 12 hours in continuation. So you can use this platform for the online platform. Means suppose you have a system of i3 system and you have a 32-bit system. Means there are very low system. While you have to train the deep learning models, the kind of things, and it will take longer time, or in some times it does not support these kind of things because your system does not have any graphics memory to interpret those images which are going to train through the deep learning model. So what you have to do means Google have provided this platform so that you can run efficiently without consuming any memory, because it takes only the memory. You have to open the Google Chrome browser. First thing, please note that please use this Google Colab in the Google Chrome. Don't try to use the Microsoft Edge or kind of other platforms. Use Google Colab, Google Chrome software, Google Chrome browser to use this platform. So I will, because already you have a Gmail account, you can log in the system. So you can check, there are different things. The main thing is the runtime. You can see along with the insert tab, then you can the runtime. In the runtime, you can see that there are different options. Means they are run or run before. These kind of things means when we type the commands, then it will run the commands. But since the main thing is that change runtime type. In the change runtime type, here you can see that there are three kinds of hardware accelerator. Means one in none, means you are only the CPU version of this. Then second is GPU, and last one is the TPU. TPU is for the TensorFlow kind of things. Means we are dedicatedly using the TensorFlow platform. Means it is not high specific speed in kind of thing, but to handle the tensor, it is you can use this platform for the optimized use of the tensors in your program. The second one is the GPU. The major thing that GPU. It is the K80 GPU, means that comes in the around I think 6 lakh rupees that Google is providing free to all of the user for 12 hours. Means if you, because most of the CNN programs take only 1 hour, half an hour, and you can train multiple runs, then it will refresh the thing. Then you can use the second day also. Means it had that 12-hour time for one session. For maximum session is 12 hours. So you can use GPU. So if you so for using GPU means you have to click the GPU, then you can save this button.
Can you just repeat the thing, please, if you don't mind?
Yeah, I will repeat.
Yeah, thank you so much. Thank you.
What happens means our systems, our normal systems, which are very limited, means we have all we have a system that is cost below 1 lakh rupees around. So, but the GPU the Google is providing is around 6 lakh. Means so you can say how efficient it is to run. So one advantage of the Google Chrome is Google Colab is means you are running the program in online mode. Means once you prepare the program, then you can run even through your mobile net also. It only consumes a single net. All the processing is going on the cloud. One thing. Second thing, it is providing the GPU. means there are, once you open this, the default mode is, it is choosing none by default, but you can choose GPU, means in the, I will telling you, from the runtime tab, change runtime type, then you can use GPU. Then you can choose GPU and you can save. Then it will show the first thing. Second thing, it has the connected browsers, means what are the means, because it means you are running the program, means you have some database, means where you have to store the database in the online cloud. There it will, once you open this tab, it will showing that connecting to a runtime to enable the file thing. It shows the three options. One is simple, upload to the session storage. Session storage means you have a GPU, it has a 12-hour sessions. That means you are storing to some cloud storage that is for only for the 12 hours. Means once 12 hours complete, that means your session is complete, then it will refresh. Means all the data will be lost. That is the upload to the session storage. Means if you have you have simple for you have 1 or 2 hours, then you can work. Means if you, but you have, means you are working for 12 hours, means you are storing the model, then you can't use this model, this thing. But if you are a small time duration to run the program, then you can use this thing. Second one, the option is showing refresh. Refresh means once you load the program, means suppose that I have some programs, I will show, means I have some programs or data, that means it is not showing that that time, but means if you refresh that thing, that means it will show all the things as a simple as your command in your basic desktop. The last is the main function is the mount drive. Means mount drive means once you click on the mount drive, that means it will link your Google Drive account and the Google Colab. Means it can with the permission, it can fetch the data that is stored in the Google Colab. Means if you have, means suppose you are making a program for a plant leaf classification, or you can say a flower classification. Means one image, means you have stored the image database of the different flowers in your Google Drive. Then you can fetch the data from the Google Drive. So what you have to do, you have just click the mounting the Google Drive. That it will show some show, means you have permission, ask for permission, means connect to Google Drive. Once you click that, it will take you to a different tab. It is showing mounting the drive. Now see, initially only the sample data folder was there. Now it is showing the drive folder. The drive is for the Google Drive link. Means I can show this is the my drive. Here in the Google Colab notebooks, means whatever program I will run, that will store in this folder. Initially, what I have used, means I have made different data sets, means that is for the chest X-ray, means I have stored different data to train the ring, means one is for test data, train data, means we will show in later classes. But there are some data. If I have to fetch, means different data means for different classes, then I can fetch this data. So there are different things, mean you can run them. Means if I want to import the data, means you have to right click on the data or whatever folder or a file, then it will show the copy path. If I paste that path, it will show the path of that. Means where it is content, drive folder, drive in the my drive folder, and Google Colab notebooks in their folder chest X-ray, then in test data, and their file name is. Means what I'm telling you, means you can integrate the Google Drive, means you can store the things in a Google Drive and you can fetch the data in the Google Colab. Means so you can efficiently use the Google Colab platform for the utilization. So I'm briefly summarizing things. Means what you have learned, means we have the two platforms. We have one platform, Google Colab repository, you can say. Means this is Google Colab, means which provide the online platform to run deep learning and machine learning models. You can, means easy platform you can run. The second thing, you can associate instead of using the storage that is providing only for a 12-hour session, you can use the Google Drive to make your data, means whatever you're programming, you can save the Google Drive at the same time, so that your data will not be lost after a 12-hour session. So you can effectively utilize after combining the Google Drive and the Google Colab. I'm just repeating the steps, what I have done. First, I had signed with the Google Gmail account. You can sign in, means you can ask the Gmail ID. I've already logged in. I'm already logged in. So it is showing my Gmail account. I'm already logged in. So then you have to search Colab. You can also go to the colab.research.google.com. Otherwise, if you are simply new to this, then you can search Google Colab, and it will show the first option, Google Colab. Then you click this option. What I have already told you that if you want to new program, then you can use new notebook. Otherwise, you can cancel these things. But what you can, after canceling, what you see, there is some inbuilt help section that already a Google Colab built, means there are something that you can say, means how it is working. Then you can learn that if you are new to this, then you can learn these kind of things, means how to plot the graph, how to train the things, means there are more resources also, means you can different sections, means different data sets also available that are associated with the Google Colab. Google Colab providing the efficient means easy platform to how you can utilize different data sets that are already available, means after combining them manually, there is you can, I think if you are working in research, then you have already used the Mendeley software, means otherwise if you are not used, means there are different data sets that are using from the one repository that known as Kaggle, Kaggle, means that is what, that is the online data set, means that that also organizes the different competitions in the field of the machine learning and deep learning, so that so those data sets are also can utilize from this thing. Means so one thing that you can you have to, means how to associate different things. You can learn from the Google Colab itself. So it is showing machine learning, that it is showing how you can show how TensorFlow 2 or different kinds, means whatever you learn, means how to use the TensorFlow with GPU, means different kinds of things, means some already a program also there, that means some text classification, means there is some means IMDb, you can already know that the different movies are released and there the database for IMDb, different where user can give the reviews also, means their text classification using the other positive, means you can make a system, means they already build a program, means you can see I'm opening that program, means it is showing some program, means there is, you can know the data set, means which means you have to train the data set, means you have to make the machine learn, means how from the past experiences of different users. So you have to train data for that, means you have trained the data, then you can export data, you can easily run these things. So there are different programs going on, means then you have the different, this is the deep learning model, then validation set, this is the training for certain iterations, 40 iterations it is going on. Then you can evaluate the performance of the model, means you can how accurate this is the model or not. Maybe it is showing some loss, some accuracy is the 85% accuracy. Then you can plot the graph for that. Means a kind of, means whatever the kind of things that you require to perform a deep learning model. These are all things that are already given. You can try this program. You can search text classification with movie review, Google Colab, and you can run. How to run? Means this is a simple program that I already done. Then you can copy the copy section, then you can copy the program also in the your Google Colab notebook. Then you can run these programs. They are very simple. They are already provided by the Google Colab. Means here you can make a movie prediction system. If you have a time, then I will show this program also. But you can all try by yourself if we do not have a time. We will. But this is a program, means how different things that Google has already given, means if you are new to this thing, then you can adapt these things. So I think so you are comfortable to using the thing, means you have to just sign in the system, then you can use the Google Colab platform. Then if you have the you have your own program, you want to write new program, then you can click on the new notebook, then it will show the new it will show the tab, even line by line section where you can program things. It is basically for the Python platform. It also supports different programming language, but the major it is for the Python. Means if you need support that, if I have a program that import TensorFlow, that means this is a library that I want to import, then what I have to do means you have to write the things, means I importing the library, I click the thing, It is running the program. If you see the circle around the play button is moving. It is running the program because it is connecting to the session. It is initiating session. Once session is start, it is connected to their GPU server or whatever server it is running. It run the program. Means that if you next program means if you want to visualize the things means if I print something, means print, you can say there are simple things because the Python is very simple. If you are new to this, then you can also adapt because the commands are very simple. Means what I have write print then hello means some only for syntax means you have to put in you have to write the program in the inside the brackets. Then you're simple. Then you can print hello. Then you can means whatever you want to do means different kinds of things that you can perform this thing. I will show, but what the commands in the Python are very simple. So then you can that you whatever I have shown previously, then you can click on this folder button. Here you can see that I have not mount my drive, so it is only showing the sample data folder. If you want to mount the drive, then I can mount the drive from clicking this. I hope all you can understand these things. So this is for the Google Colab section where we will run the programs. The second section is the Anaconda platform. Once you have downloaded the Anaconda, for that was the mostly we are running the Windows 10 platform, so that it can it will show you the Anaconda. Then you can simply next. You can simply whatever install. I have already installed the program. Then you can open the Anaconda. Then it is show the Anaconda navigator. Means I will show means whatever the inside. Once you click the program, then it will show some tab. If you have some having a system with the less time, then it will take some longer time. It's about a minute. But if you have a good system, then it will open within a minute. Then whatever it is Anaconda navigator means it is the compact pack means Anaconda is providing different ID means these are the different IDs. That is the notebook, Jupyter Lab, Jupyter Notebook, Spider. These things you can already see means it is the Anaconda framework. You are learning means it is for the offline work. Means if you want to develop a system because you do not want to internet resources also, then you can if you are good system, then you can install this thing. Means you can install in your IT system also, but you can install these things. Then once installed, these things will come up. Means it is showing different things.
Yeah, I have a small question.
Yes, yes.
Hello. In case you are having a previous Anaconda version installed in your laptop or system, then in that case, shall you have to uninstall the previous version for installing this one or what?
No. I'm not. I have already installed, but I am not installing again and again. But you can install because some people because we are new students means they are not adapted to this different environment. So I am telling the things means for the beginners also. You can use these things. Means I'm telling means if you have already system you are using this, you already catch up things very easily because you have already used the Spider thing kind of things. Because if I directly telling the Spider or directly teach the program in the Google Colab means if the person don't know what are the Google Colab, what is the Anaconda, these kind of things means how the platform is going on. So that's why I'm telling these things.
Okay.
So there are different platforms. Means one is the notebook. You can launch the programs. You can launch from these IDs from here. There is a launch button. You can also launch from here. Otherwise, if you have Windows, then you can search the simple means if I want to launch the Spider, then I will search the SPY. Then you can say Spider and type the name of ID or simple SPY. Then it will show the Spider program, Spider Anaconda 3. Then you can run this program. Similarly, if I want to use Jupyter program, that is spelling or some change, that is not Jupyter, that is Jupyter, GPPYTER, that is Jupyter. Similarly, for the Spider also spelling the SPYDER, not SPIDER. So please don't confuse. So for the program SPYDER, similarly for the Jupyter, JUPYTER. These are basically two IDEs which are mostly used by the programmers in the Anaconda framework. So these are two. But means when to use the Jupyter and when to use the Spider means there are two things. Then means where to use, means how to use. So if I show, means I have already told you the Google Colab, then I will show first the Jupyter, means Jupyter, then you open, or you can directly open from the Anaconda prompt also, means where you have Anaconda Navigator, then you can also the launch button. Whatever is suitable to you, then you can. Whatever what it use the browser, means it is showing the prompt, means it is connected to something. It open in the your if you are using the Microsoft Windows 10, then if you using the Mac browser, you can use the Google also. But it is I have already in the basic browser is Microsoft Edge, so it is choosing this thing. There is no difference between the whatever platform you are using, but simply this is opening in the Microsoft Edge. I am repeating, means once I have opened the Jupyter notebook, I clicked on this, one black window come up that will show, means whatever going on this thing, whatever the IP connected or connected to servers or all the connection are, means whatever things are going on that thing, they summarize the things in a black window. But where is the program, where you have to run the program, that it will going on the Microsoft Edge, that is a browser that you can usually use, that it can go in the browser. Then you can similarly, for that, if you have already some program, then you can choose that program. Otherwise, you can whatever you can click. Then there is some new tab, means the upload section. Then here is new, means you are into Python 3 notebook. Then it will open some new notebook. Correct? It is similar to the Google Colab, or you can say that both the Google Colab and Jupyter are similar. Means the notebook version. Means when to use the notebook version, means when you are using the running the code section by section. Section by section, that means you have some segment, means you are segmented the code in something like that, means you have one time you want to import the libraries, then second time you want to import the data, second tab means support that, means I have program like that, means I am importing TensorFlow, means I'm importing OpenCV package, that is CV2, means I have importing this package. One section is this. I want to add next program level, means I want to say, means A equal to some program, that means I am using CV2 dot please don't go into I am just showing, means example, something like that, means I am open some image, that means some like, means I have some email that kind of consider, means I have different sections also, means when means I have choice, means I am running the program section by section. I am running the program separate, means once I run this program, then you can run, click on the run, then it will run this room. It will show some star mark on that. Once it will run, that it will show the numeric number, means how many times you have run. Means if I click again, that it will show 2 command number. You can follow the commands also. Similarly, the second command, this image does not exist presently, so it will show some error. But you can run this program simply that Rakesh image.read, means if you have this program, if you show this program or something like that, then it will show, means CV2. Means there are different sections, means I will show different things, but different commands. If you want to run all the section, means you do not want to run the section by section, but you want to run, so you have to go to the cell tab, then you can run all. So there are different options, run all. If you are in some in between section and you want to run the section that are below that section, then you can choose the run all below. Then similarly run all above, according to the whatever commands you want to run at a time. So you have flexibility what you want to choose. Similarly, so it is more flexible when you are working some section by section, means once you want to load a library, once you want to train the thing, then after then you are testing the section completely. So it is very good platform for that. That is notebook. Mostly prefer Jupyter if you are doing subsection, means you want to interpret the things very easily, means whatever is going on things. So there are some, if you want, I am adding plus sign, means plus sign means that it will insert a cell. I am choosing the code section, so it will showing the code section. If I show the some markdown or means heading section means I will so had some heading means that will not run means that are not part of the thing, but I want to make the thing means suppose that then you can also when I have to means when you can also shift the sections also means they are up down arrows, then you can shift means I want to shift that thing, I can shift up means suppose I am telling you means I want to make the user means if you are the program thing but the other user is not able to understand whatever program you want, you can make comment sections. So you can write the thing, I have the markdown edit, I have the markdown, so I can make them understand means what is the command for. So I can say that is the opening the image using open CV library, you can say means you can explain things means these things. So means whatever command is for. Similarly, if you run the thing, these are the command sections. This is only the comment section means you comment only because it will not part of the program. The second thing is the program means checking over means they are different programs. Thus, so similarly means if you are working on a Google Colab or similar, you can file. The one thing, what is that? Once I will save the program, it will be showing the different things means I want to store that program in .py format or something like that format. But the basic format for when you are using the notebook, the default format is NB. If you are using a Py, that is .pynb. 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 This is the syntax, means extension for the file that will be shaped. Means the Py is representing the Python and NB representing the notebook. Means all the notebooks are storing in this format, basic format. Otherwise, you can also store also in different format. But basic store means basic the format is extension is the .pynb. It is for the Google Colab as well as for Jupyter Notebook. So this is the .pynb format, .pynb extension, so that you can save the program. So if you have a program that .pynb, then you can open using the Jupyter, and then you can also open if you are online program, you are run online, that you can open from the Google Colab. Similarly, what is the second platform? Second platform IDE, the Spyder, SPYDER. I clicked on that icon, then it will show the Spyder. We have different versions of Spyder 1, Spyder 2, Spyder 3, Spyder 4. Mostly, if you have previous version, that is Spyder 3, and the current version is Spyder 4. You can change the preview and color also, means according to you.
Yeah, can you just tell us like which version is better actually? Which version is better? In you have to go for what you call Spyder or notebook. Which one we have to use for the
means whatever you have to use means. I will tell means once I will tell I will compare both the things and I will tell both the whatever I will compare both the things means whatever is suitable and
okay.
There I have already opened the program. Means suppose that you have program that you can open means this is the some the whatever the preview is looking like this. Then you can see the means it is looking like me. There are some, if you have used MATLAB kind of things, then you have means we have different sections also. Means we have some there command is going on, some there is the variables are visible, something like that. Means it is kind of that platform. Means if you are adapted to MATLAB, then it is very easy. Then you can follow the things in Spyder. But whatever things, first thing the difference you can say when you are using this program, then your program will be saved because it is only a single section program that will saved in .py format. .py only the Python.
Yes.
Means we are previously that was pynb.
Pynb is for
notebook.
For the notebook,
Either in either a Jupyter notebook or either you can say a Google Colab notebook. I mean, whatever notebook you are using, that is extension is for pynb. Right? Then similarly, when you normal Python, you are even using a PyCharm or you can Spyder, different Visual Basic also, that .py. Correct? Once if you have a program, then you want to open the program, whichever you prefer. If you have a .pynb format, then you will prefer Jupyter. And if you have .py format program, means already built program, then you will open the Spider. How you are opening the program in that point of view. Means suppose that you have a .doc file, then you will use the Microsoft Word option. And then if you have .xlsx format, then you will use Microsoft Excel format. Means in that perspective, then you can use the extension based on extension. Correct? Whatever thing means here only if you are seeing the program, that it is only a single program. Correct? It is only a single program. Once I run the program, that it will run all the things. It will run all the program. Correct? And there was the facility in the Jupyter, then you are running the section by section. Correct? The basic facility means there also you can in the Jupyter notebook. There was you are also in the situation that you can run the whole program also in one time. Similarly, here also you can run the different section, but that is the you have to make that is not means that is not made for that thing. So there's some button like that. Means run the current cell. Means if you make some cell kind of thing, that you can run the current cell. Then if you can move on to different things, means run current cell and go to the next. Means you can make different cells also. But basically it is for the, means they are different IDs. I mean that in notebook kind of things. Means notebook means you are page by page kind of things. Means you are using prefer to use to different kind of thing. Then if you want to run the whole program, means that is not up. You can you can't say that the I will only the single cell program will be run in the Spider, and you can say multiple section will run on the notebook. But basically, whatever program structure we use in that direction. Otherwise, we can use the cells also in the Spider, and we can run the whole program in the Jupyter. Correct? But basically, when we make some program, then you can .py format we have used means a single section program that we use to preferably use to Spider, and in the multiple section program we will preferably use notebook. Otherwise, we can do things in both the things, but the basic structure for the Spider is one section, and similarly the for the Jupyter it is for a multiple section. You can run a single section also, but for you can better understanding also, right? So there are different means whatever see means there this is the command prompt. Means there you have to write the program. Means whatever program I was writing means import something like program means I'm importing library, then functioning something like that comes kind of things, and you can write a program. For run there is some green button, then you can run the program. And similarly this is the variable. Means once I run the program, it will show in this section console section that it will show means I have wrong program, but it will show error, but it's showing error means I'm running the program which is located in some certain location, and I'm running the command and it is showing some error. Means it is showing the syntax error, and it will be showing the invalid syntax because I have not imported any library and kind of library means I am not mentioned the library. Then it's showing the error. Means here here you have to write the program, and in section and console section there is whatever program you are running, that it will show the variable output whatever you put in the print or whatever mean those variables, and whatever program you are running it is showing in this section. Similarly, there is above in the variable section means there is, if you have allotted some variable means if I have stored means like x equal to 9, y equal to 10 means if I have allocated some variable and I am running this program, then it will show means same error. But if it's in the variable explorer, if there is some okay, I will show in next program means suppose z equal to x plus y. I am printing print z. Sorry, it's a program. See, I have some returns of program means x equal to 9, y equal to 10. I am some second variable z equal to x plus y, and I am printing the z variable, right? So these are the what are the variables x, y, and z. You can see x, y, z are variables, and whatever the output is the z is the output. So I have write the program in this section. Whatever I am running location and section, that it is going on this console. And whatever output, the output was the 19, that output is also showing in here. Similarly, what are the variables that are showing in the variable explore section means X, Y, Z. Those are the integer values, size 1, then means 9, 10, 19, means the value are the 9, 10, 19. So these are the things that are that you can see means you are writing your program, then you are showing the your outputs are here, means if you can, whatever you can see means you can print you see the value of the Z is showing that the value of Z is the 19. One thing. Second thing, the basic structure of the Python programs are like that, means you have to import the library, whatever you want to use, means if you are not a basic function, otherwise if you are a standard function, means if you are want to image kind of things, means you have to library, you are various library that are already inbuilt, then you have to import those library for that and use the function corresponding to that. So the basic structure is what? Basic structure is that means you have to import the library first. I want to work on some image kind of things. So I'm importing the library, import CV2. That is a command for import CV2. Correct? Similarly, if I want to use means you have library. It's better to I think show some program also. Whatever is going on, I will tell. This is the one program that is for your face detection or smile detection. This is for face detection and smile detection. So first see the basic structure, what is going on, not see what is going on, but the basic structure is means we have imported some library. We are importing some things, means some variables and some running some program, and then we have some video release and CV to destroy all window, means whatever the prompt is coming on that we have to go to these things, means so the basic structure of program means you are importing some library and you are running something, correct? I will tell more about this program once I finish all some basics. So the second thing means you can also see means if I have some program means I'm import CV2. There is some, if you see, if you install this program, the kite, there is some section that written like a kite, KIT, that in each below section that is show kite ready, or sometimes it prompt that pre-install kite. What is the use of this kite? Kite help you to predict the functions very well. Means suppose I want to, because you don't have to remember all the commands kind of things, because that is not your work, means what is the function it means. So what I have to do means I'm writing CV2, whatever in MATLAB, that it will show some functions that are related to me. I have typed CV, means that are showing that a CV2. There are different modules are already there. So I can I'm showing again whatever I have typed CV, then press the tab button, or whatever. If you not press the button, it will already show the modules which are available already. Then I have pressed CV2. I want to read some image. Suppose that the function is that I have input library, then I have to press the dot, means from this library. It is showing different functions. CV2, I am show, I am read, CV2 color, wait key, I am write, resize, destroy all windows, rectangle. These are different functions that are already built upon the CV2. So the first thing that the Python is very simple, means you can understand from the command, means whatever the I am show, that means you are want to show some image. I am read, you want to read some image. You want to resize, that means you want to resize some image. I am write means you are saving some image in directory. Similarly, there's a very similar command as you have used in the MATLAB also. So if I do I am read, I am press the I am, then I am pressing the tab button, that it will show different functions as well as their syntax, so how it is going on, because some parameters demands for the multiple variables and some demands only for the single variable. So it will show some structure also for the different program. It will show the list. If I am scrolling that program, means there are different functions. I am write parameter, I am reduced, I am right PNG, and different kind of things, then you can easily understand that I am using some read function, the I am read. Then it will show whatever you want to choose, then you can press the tab button also after choosing that. The I am read button. It will show in the I am read, then it will show some help things, means it is what is what? It is I am read function, and it will show that it is demanding for some file name. You can set some flag name and you can choose this thing. Means some are very required things that are showing in some yellow section, and some are optional things which you can put the things. Otherwise, it will take those at default. So I am reading the whatever it requires a file name. If I have some file name, means if I have saved some variable, then you can choose I am A. Otherwise, you have to give the file name with address. Means some image, otherwise I have shown. Means you can choose that image also. Means you can use different commands also. With the help of Kite, you will see different options very easily without learning means these kind of things. So I have all the basics. We will clear these basics in the upcoming sessions also. But I hope means you have some basic things. Means whatever going, whatever we have to type, and what is the where is the output, and what you have means whatever the syntax kind of things you will you have. I hope you have grabbed those things. Now coming to this workshop, means you are learning the things in kind of things, means you are learning machine learning, you will learn deep learning upcoming sections. Means they are different programs. Means what is the basic thing, the machine learning what means you are learning from your past experience. It means you have make the machine learn some things, means some you have given some parameters, you have learned means some these are kind of some things, then you are making the prediction according to the trained data to the means you are giving some test data, and you are telling the system to predict according to his past machine's past experiences. Means whatever it means, if you have trained some data set of the faces, means you have human face images, then you are training some images and you are giving some image kind of things in a human face, that it will predict. You are telling the machine to predict what is this. According as you have as similar to the child, means you have demonstrated different things and you have told the name of those things, then the child or similarly a machine can recognize those things as per your the training, means how you have trained the things and how much data you have fed that. Means suppose that if you have, means I am trained the data set with the faces and I am only the faces, means suppose a child is born, I am only showing the faces only there, and according to that I am showing some face to the child, or you can say machine, which have already only learned the faces only. So if you show some face, it will predict this is the face. If you have trained some flower data set, then means it will show that it is a flower, and it can also, if you have multiple variety, then it will show that this is the flower or this is the rose kind of thing. So, so it will predict. Right? Second thing, once you make the model to predict these things, so similarly for that I have made some program. It is a basic image processing program, but that has the values. Means the values means this is a program. Objective of this program to detect the face. The second is that to check the smile. It is to check the face and the smile. So I have trained. There is I have imported. I will tell you these things. This is import CV2. Import CV2. This is the OpenCV library that is basically for image that help to handle the images. That is the library name is OpenCV, and you have to import this. Right? All the library are not built in the Anaconda, so you have to install the different library also. Means because I have already installed things, but if you are new, it will show the error. It will say that the CV2 is not available or kind of things. Means this is the not package is not available. I import. It will show the import package. Means whatever you do, you have to install those libraries. Whatever you want to use, some specific library you want to use. So how you can install those libraries, because this is the programming things, but the required things are the libraries, and all the libraries are not inbuilt. And some versions, means if you are using TensorFlow, and some versions, all the programs are not supporting that. You are version TensorFlow 2.0 and support only the 1.13.0. So you want to specifically install some programs or some libraries. So specifically install the library, then you can install how? You have to press the window, means you can search the library, means I have pressed the Anaconda. Previously we have went to the Anaconda navigator where we have shown the different IDs, and there in the blue button, the Anaconda prompt. You can directly click it, then it will show black window, correct? But it does not have any administrative privilege, because if you are installing the program in your system, and some programs require the administrative privilege to install those things. So what you have to do, you can require it's better to be in a normal user mode. You can install the things in an administrative mode. Whatever you have to do means, similarly, you have to open Anaconda. If you type only the Anaconda, then it will show the Anaconda prompt. Then it will show the second option, run an administrator. Otherwise, you can right click on that, it will run an administrator. It will show some pop-up. Then you click yes, then it will show some program, correct? Then I want to install some library. I want to handle the images, and the perfect library is OpenCV. I want to install that. What I would do, I have to install things. There are different commands, means there are different repositories where we are fetching those libraries, correct? Whatever those repositories, one is the PIP. One is the PIP. One is the PIP. Sorry, PIP. One is the PIP, very famous. Second is Anaconda also has a repository of different libraries, Conda, correct? There are different libraries you can install, PIP. And similarly, if you are installing from, if you are installing from the Conda repository, then you can install that from the Conda. So there are one PIP and second is the Conda, correct? Means you can install the different library from different versions. Means Conda also built. So I will show. Means I want to install some OpenCV. Then you can type PIP. Means the repository is PIP. Install. Then I want to install Python. The command is Python/OpenCV. Correct? Whatever I am telling the things, means you have to fetch from the PIP, whatever you do, install, and whatever package name is Python OpenCV, correct? Then I'm pressing the enter button. You can do it parallel. I'm pressing it is showing some, it is not, sorry, I think I have wrongly typed. It is OpenCV. It is showing the requirement already satisfied. Please note that, sorry. There is PIP install OpenCV-Python. PIP install OpenCV-Python. I'm telling you here. The command is PIP install OpenCV-Python. Please use this command, PIP install OpenCV-Python. Once installed, you can fetch that in the, because it is installed in your system, then you can fetch. If you want to check only that library installed or not, then you can type in the where you are seeing the output, that you can put the command also. Means I'm typing import. The OpenCV commands come into a CV2, that OpenCV version 2. That is version CV2, CV, small cv, then 2. I'm pressing the enter. If it was not installed, then it will show some error. it will show some error. If you have not installed, then you can try once from typing in your console of the Spider, then you can press enter. It will show the error. Then when you install the things, then it will not show the error. Means suppose if I have installed some random, I am typing some random, means they know some program that like workshop today, something kind of thing, means some package name, something like that. Means I am pressing that thing. What are you showing? It is showing some error. Module not found error. Similarly, if you have not installed OpenCV, that will show no module named CV2. It will showing error in line 1 kind of things. Okay. Then you can run separate lines here. So I have installed the things, then import CV2. It is not showing any error. Correct. Similarly, the time is the basic function that is already installed in your Anaconda.
Mr. Rakesh, I have a small suggestion. Mr. Rakesh.
Yes, yes.
Yeah, the thing is that, is it possible for you to give this particular code, because typing this code will be difficult for us, in the chat, so that we can copy and put in our...
I will definitely. Because that's how it will. I will not make you type the things because right? It will take a longer time otherwise. Because there are some variables and there are some caps function and something like that. That will show some error. But no, I will I put all the program, but I'm making this program only for the basic structure kind of things. I will make things program. So you have imported the library. So I have told you means how to install the libraries. You can install different packages from that. Means otherwise, suppose that I am new to this thing and I want to install things. I don't know what is the package kind of things. Means I want to check how to install these things. So I am checking that how to install OpenCV. Correct. When I type the how to install OpenCV, or you can say how to package different things, you can already the Google will show different options you have to. What you have to rely upon? One is the pypi.org. I have already told you the PIP repository. This is the pypi.org. pypi.org means I don't know. I only know that my program required. Please mute the mic. I only know that I have to use the OpenCV library in my program, but I don't know how to install the things. Correct? So what I have to go to the Google, or simply for your information, you can note the pypi.org. Website is pypi.org. pypi.org. Pi, correct? Pi for Python, Pi for PIP library. Okay? PIP, sorry, repository. So this is the thing. Now, once you search the program, that it will show the command. Whatever they have simplified, you can only click on the copy to clipboard button. That here the command is written upon. Then copy to clipboard. The command is copied. Then you can paste where you can say. Then you can paste the things here. And then you can install the program. Correct? Means when you have to search for different library, then you can search upon, go to the Google, and you can open the pypi.org. Similarly, if you want to install from the Conda, that means you can say Conda, then Conda install, you can say I am typing OpenCV, correct? So, because this is not the correct command, correct? It will show the anaconda.org, that is Conda for FORG, correct? This is a repository where all the commands means to show the command. It's like that it is showing the pypi.org that you are showing command. Similarly for Anaconda for the repository, it is showing different commands. See, this is showing the Conda install -c, Conda for OpenCV, correct? They are different versions, correct? But the story is not yet very simple. When you use different programs, when you install these things, the things means why I have installed only the PIP, because I know these program can not work properly sometimes in my system. Or correct means you have means once you go to deep in the programming, you have to struggle for different library also, because different system has a different requirement and different types of configuration which they require, and sometimes all the means if there's some error, then it will not install. So you have to explore the things means where you can install. Means if suppose I have tried the conda install something like that program that was not installed, so means don't stuck in that, search for the PYPI library, PYPI repository, then you can install from this. Right? This because we are working on this domain, and sometimes not means I was working in this thing, everything went very good in the when I was working with the Windows framework. When I go to the Linux, there is some means those commands not work properly. Right? So be ready for that. Means we are there, but I will tell the most which we are running properly. So you have to install PYP install OpenCV.Python for the OpenCV. Correct? So for this program to run, you need only the one library only to install, that is the OpenCV library. And to install that, please note that you have to install with PIP. I've already told you you can search also, but you can search also means by your hand. Means PIP install OpenCV hyphen, you can say dash Python. Correct? If you note it down, it will be well, but otherwise you can search these things because they are different library you have to search in future. Okay. So PIP install OpenCV dash Python. Correct? So what are the basics means what are the things required for this run program? That OpenCV library. To import that, we have to use command import CV2. Correct? Now we will run the program. Correct? Take it as an assignment means you have different variables and please change that. Change that means they are different means it's one in the scale factor here written here 1.1. Then you can change 1.1 to 1.5. Then you can change the 1.12. Change the different things, not the coordinates. Otherwise, minimum neighbor means scale factor and minimum neighbors. Please change those things, those parameters. You will see different changes, and accuracy will sometimes you will see the higher accuracy, somewhere see your lower accuracy, somewhere means you can optimize those things. So please check that means what are the going through. Correct? Now, I hope all the basics are cleared. Otherwise, if you have a problem, you can ask again. Ask what basic because we have very less time. So I have to make some this program so that you can understand and you can check means how the means it is detecting the face, and you can check the smile of your family members or you are running this program, small program for that. Correct? So if you want to run this parallel, I will copying the commands. First, you have to import those libraries. Here I have to share these things.
Mr. Rakesh, you can copy it on the Zoom group chat. There you will be getting.
I'm checking that option. Otherwise, it's not showing. I'm sharing the screen. I think not showing that option.
It is in the chat. There is an option called chat on your Zoom whatever window. Chat on the down.
Whatever you are showing here that is visible to me only. I mean, it's okay. But the same is visible to me. It is not showing so much. I'm stop share. I think so. Otherwise, I will copy. I'm now it is showing. I think so. My audio is audible. So I'm copying this thing. Means this is the command import CV2, and my audio is clear or not?
Yeah. Your audio
yeah. Please, I'm typing the commands in the chat window. You can copy from that, and we will get back to you. I will share the window after that. Correct? That this simple command you can type import CV2 and imports time. Correct? Similarly, no. What happens means there are two files, .xml files. How can I send to the multiple participants? So I think a file also. So, okay. I'm sharing some 2 files with you. I think so. I can share the whole program also. You can run that, copy that program also. I am sent one file, that is the XML file. You can download it. I will share 3 things. 2 XML files. And last one is the program, which I have shown you. Please take some 1 or 2 minutes where you can download these files. I hope everyone got the files. There are 3 things: .xml, 2 things, .xml, and one is .py, that is the program. You can open that in the notebook also. You can open with kind of from your right click. Please link. Sorry, I don't understand. And someone is saying I am from mathematics. It is simpler than the mathematics. Mathematics is more advanced. I think Python is very simple. And you will learn because they are simple, very simple commands. That is, we will see different commands. Means you can interpret the meaning from the code itself. Means what are the function it is going to use. I hope everyone have downloaded those files. Is any problem? Otherwise, I will share the screen and show the program. Everyone is responding. I think so. Everything fine and everyone is working. Let's see. Okay. Please. So, okay. I'm sharing the screen. Host.
For downloading the time library, is there any link for
No,
time?
no, that's a basic library that is already coming in.
No, because it is giving me some error.
What kind of error? No module found time or what?
Yeah, it is giving you error in function CV /CVD color. CV : CVD color in function error.
Let me check this.
Yeah.
No. If you have, whatever happens.
Yeah, CVD color is the error. Yeah.
I hope so. You are getting the same error, correct? Because correct. And me both are using the webcams, and there is only one webcam, and it is using the webcam only, correct? When you have to use this, you have to switch off your webcam.
Okay.
But please don't run that program. Please. First, I am making understand. Right? I have because try to learn as you do not have any program. So please, like kind of things. Correct? Whatever the meaning of the program, because one can run the program easily. But understand these things means there are second line and third line. You can see the phase cascade. I think so. There is phase cascade. Then when the smile cascade. These are the variables only. Then you can define by, you can say the X or Y, whatever you can say. Okay, these are only variables. But this is the function. whatever it is showing CV2 cascade classifier, correct? CV2 means this is the function from the library CV2, and what is the function? Cascade classifier, correct? It demands, whenever you go to this thing, that it demands the file. It demands the file name. I have one thing. Please save those, whatever 3 files in a same folder, correct? Otherwise, it will also give the error that are not saved, because you are directly downloading the things. Then if you will show in a download folder, it will not show the error. But if you put the file differently in different folders, it will show the error. Then what you have to do? You have to give the address. Means whatever address means, like kind of things /c means whatever library here it means, it's something like that, correct? Means with a different folder, you can give the address kind of thing. How to get the address? Means suppose that I have some program I have saved here. Means suppose this is the program, the address of that program. Means you can click on that, you can copy, double click, then copy this thing, address, Control C, and then use this. Okay. If you have different address, correct? You can use this thing. Otherwise, if you have both the 3 things in the same folder, then you can do not get any error, correct? So, we are 2 things, correct? I have already told you, machine learn from the past experiences. So what have done? We have stored different faces of different persons, of huge faces, huge number of faces, and saved in .xml file. Saved in .xml file means, because every image is what? Image is the number of pixels, and we are getting some features, and based on those features, we have saved those XML files. We will learn in different classes also, but we have, you can say, the information of different faces or the training set, we have saved in .xml file. If you open .xml file, if you can also open the file, there are a huge numeric number you can see. Those are the features, correct? So these are the face, right? Similarly, that second one is smile, that is for the only the lip section. Lip section means whenever you smile, that you open up, you cheers your lip, extend, spread your lips, and then open, show some teeth or kind of things. Means those kind of faces also are stuck in this smile cascade, correct? Means whatever you have told to the machine means, I have told that these are the faces of the faces and these are the smile things. I have trained them means .xml file, generated .xml file means I have informed means the machine, whatever machine know the faces, and second machine know the smile. Means how accurate it know, it depends on the how much data you have used to train the things, these things, or you have to generate the XML files. So these are 2 files, correct? The next line is showing video capture. Whatever this line, it line only show the address of the camera. If you go give some static image, then it will, you can give the static link of the video, or you can give the live webcam. It is showing 0. That means I am using the webcam of my laptop, correct? If I default webcam, if I want to use the USB webcam that can attach to a USB port, then I can use USB video capture 1. You can check the thing if you have USB cam. Similarly, I'm using default webcam, so I'm using video capture 0, correct? This is the basic structure. Means while this condition is true, means while we are getting the frames, correct? One thing that the spider is sensitive means there you can say the tab space. There is, you can say tab space means, it means the while is true means when the while is true that this section is running, you are seeing gap. If you remove this gap, it will show the default line. It will show the syntax error. You can say means if I say I will make you I will show after that means it will show error because it is not showing from that function also, correct? So you need some proper alignment of the function also, correct? Once if you go to this program, it will default enter that area, correct? You do not have to write from the starting of the means below W, correct? Whatever it is going, it will go, correct? Then you are reading the frames, that is the function, then check.frame means whatever it is showing left of the equal sign, then it was, those are the variables, you can change also, but these are the default functions in the right of section. You are reading the video, you are reading the video, saved section, you can already answer. Means what are you reading? cv2.cvt color means the color image function. Whatever it is doing, it's cv2 color bgr to gray. You have already know that this image you can say RGB, but the computer you have saying that RGB to it will depicted as BGR. That is BGR means they are converting the RGB image to the gray. That is function is cv2 color dot bgr to gray. Means you are applying this function on what frame? What is the frame? In the previous line, you have typed the function check.frame. Means you are whatever frame is coming from the webcam. Means whatever video is set of the frame. Means that there are set of image frames. Whatever they are coming below the 1/16th of seconds that we are seeing continuously. So their frames are coming, and you are reading. They are converting the image into the BGR to gray. Then we are applying the experiences to the machine. Means whatever experience means we are applying face.cascade.detect.multiscale. Correct? We are applying this function. Means whatever the function is the detect.multiscale, but the command is what? face_cascade. Whatever we have stored .1f.xml file. So it is showing the function that. Similarly for smile, same function is repeated for that. If the face is detected, then it will detect for the smile, and it will show the smile cascade.detector. Same functions, correct? And it will make a rectangular bounding box of x, y, whatever predict means the coordinate it will predict for the face cascade where it is detected. It will predict the 4 things: x, y, w, h. Means xy is the origin point. Xy is the origin point where you will make a rectangular bounding box. Then what is the width of that bounding box? Is w, and what is the height of the h? Means suppose I have some paint. I am opening paint. Means suppose you want to draw the face of a rectangle, correct? You have to make a, means suppose there is some person, then you want to make a face around him, correct? Then you want to make a rectangular bounding box around him where face detected. So you want, whatever information is required to draw that bounding box means where you detected means you have to need 4 coordinates. One is x, next is y, then w and h. Whatever means the coordinate of this point is x, comma y. And what is the width of this thing? That means w. And what is the height? You can, from this information you can draw the bounding box, correct? You can interpret in this mathematics also. Means suppose you have 4 coordinates, then you have origin point is 0, 0. That are x value is 0 and y value is 0. I am drawing a rectangular box. What is the intersect is 3 and it is 2. Then whatever information required means there is some rectangular bounding box that is originating from 0, 0, and the width is 3 and height is 2. Correct? So this information is interpreted in this program. Interpreted means where the xy coordinate are distinct, and it is making a bounding box x plus w and y plus x. You can see the program means whatever this point, if this is the x point means the width is w, that the point is x plus w. Similarly, what is this point? Y is a basic point y plus h. Correct? Similarly, this is y plus h, comma x. So x plus h, comma y plus h. Correct? These are points. Similarly, we are information that the means when the face is detected, where the features are matched with that feature, so that it will make a bounding box around that. Whenever the bounding box is made, it will search for the smile face. If the face is correct, then we want to show the image. Means whatever detected is not. Means we want to some prompt like kind of things. So we are showing that image. I have already told you cv2.imshow. imshow means you have to show the image. What is the name of the window? You have to put this thing. I have put the face and smile detector. You can think that my family or whatever means whatever write. You can write, and whatever is showing the frame, whatever input frame you are showing, that input frame you are showing. Please note that when you are using the OpenCV program, then you have to provide the wait key and the break functions also for the OpenCV. There is a limitation of the OpenCV. Then you, if you are using the live webcam or you want to show the image, then you have to provide some wait key below that. You have to provide some cv2.wait key, or you have to close the window. There kind of thing means there are syntax. Otherwise, you will get the error. Means it does not end with only the image show. You have to provide some wait key. Means whatever means suppose that that will display the image rapidly, but you want to see the image. If some image that means comes in the front of you within microseconds, that means it will show. Means it will show, then disappear. So disappear. Correct. So you have to make some wait second. Otherwise, it will not display. Otherwise, you can say fluctuating time kind of things in your window. Correct. Let's run the program. So I'm closing my webcam because we are using the webcam in this program, and you will not display. Correct. I hope my screen is visible. Now I am running the program. How I have to run? Means I have to write a program. Then you have to run the file. Means file. Right? I am click the run button. My webcam is on. Oh, sorry. Because I have made understand from I have missed the backspace on a multi, so it was showing some error. Now it will show some window, correct? Now simple face. Then you are missing. You have to say simple face. Then it will detect a face. Then if you want to smile, that means correct. Means correct. Now you can change these kind of things. These kind of things with the variable that is scale factor 1.1 and 5. Correct. They are the minimum numbers. Minimum numbers means number of bounding box should be separated because it can make different bounding box around it because face is detected, different functions going on. So avoid different faces. So we have command that minimum faces. So you can use this command and you can change the minimum number of kind of things and you can check the accuracy. So I hope you can understand this kind of things. So these are the programs you can. Yes?
Can you just repeat it once again? Just once more. Can you just repeat?
Changing the parameters.
Yeah. No. From the beginning, this particular thing.
Yeah. Program.
They're running the program. Yeah.
Okay. Definitely. I will tell. But the first means we are different programs that close this. Means see, I'm closing. It will appearing again and again. You can see it is appearing again. I'm clicking the red button. That it is appearing because the command is correct. Correct. How to stop? You have to go to the program. This is a red symbol. Stop the current command. I have the stop command. Correct. Now the command you can cut the thing. Correct. Similarly, because there is keyboard, you can also press the Q or escape button also to close the thing. Correct. Then if you want to reset all the things, then there is some line bar means you can say restart kernel. You can say control plus dot, you can press the thing, then you can restart the kernel and all your things, whatever variables you have allotted, will reset. See the variable explorer is now empty. Correct. All the means all the camera, whatever you open, then all will show. Correct. Now see the program means first we have imported the library only because we are dealing with only the pictures and nothing we need. So we have only need the OpenCV library. Then we have installed the library with the pip install OpenCV-Python. Sorry, I think Python.OpenCV, whatever it is. But install that from the Anaconda prompt. Then imported the library. Then we have imported the means whatever you have to means machine learn. So we have imported two cascade files of the face and smile. So there is two cascade files. One F means F for face, and second file is for S. That means for smile. So there are two files. You can rename also in the file, but you have to change the program also, simultaneously also. But means you have to imported those files. Then you have opened your camera. To open your camera, that means video capture. 0 for the default webcam. Then 1 for your USB webcam. IP address for your IP webcam. Means you are there different things. Means while this function is true, then you can read the frames. Means that is a video. Means the video is a set of frames. Then you want to process only single frame at a time. So you have to fetch that frame. So we are functioning that check dot means frame. Then video read means whatever video is going on. That means we are capturing the frame of that thing. Now because the feature extraction is very easy in the grayscale. So whatever it means converted because the XML file is prepared like that. So we have to convert that color image because we are capturing the RGB image to convert that RGB image into a grayscale image. So we have to function cv2.color.bgr. The BGR is same for the RGB. So BGR to gray is a function, and you have to give the input frame, name of the frame, whatever frame is capturing. So you can convert the RGB frame into the gray frame. Similarly, now you have to detect a function. So you have to make a function that means from the cascade file, means phase underscore cascade, then you can detect a multi-scale. Then you can, you have defined a function, you can open the XML file. That means you have to, means gray means that is the grayscale image. On scale factor means 1.1 that we have chosen. We can change the things. And minimum neighbor means we do not want to collide multiple numbers of rectangular bounding box around the face. So we have chosen minimum number 5, correct? Similarly, to make a bounding box or rectangular bounding box around that, so we have to make a coordinate, define the coordinate. So it will give the output as a XY, and we have to make a bounding box for a information. We are needed for information, means where we have to orientate, that is XY coordinate, and what is the width, that is W, and what is the height, H. Similarly, for those coordinates X, Y, W, H in the face, then we have to, means because you can't, you have to make a program optimized way, means you can't search the smile, then you are searching for a face, because where the smile is on the face, so you have to first search for a face. Once face is detected, then you have to search the smile. If I make both smile and both things in a parallel, it will show the delay. Means you will not see the continuous video. It will show the fluctuation in that, because once it is show the face, then it will show the search for the smile kind of thing. Correct? So we have to think, means once only the face is detected, then it will search the smile. Correct? For make optimization. Now you want to see, means whatever it is showing or not. Correct? So we have to make a display kind of things. Then we have to put the name of the display, that is face and smile detector. If you have noticed that this will come up on the window above portion, that is face and smile detector, and you are projecting the frame. The frame is, that means you are projecting the whatever frames is coming from the video capture. We have defined a variable frame, so you can check. Then second is the weight key. If you do not provide the weight key, the whole fluctuate, it will come in a microsecond, millisecond or microsecond, that will not visible to you. Means the frame come close, correct? You will not see those things. So to make that thing, so you have to provide the weight key, otherwise your program will not run. So similarly, you can say when a program is closed and CV to destroy all windows and video release kind of things. Then you have basic function, but you have also provided a if key, whatever press key Q. If you press the Q button when you run the program, then it will close it will break the commands, and it will destroy the window. Correct? So once I am again running this program, it will switch on the webcam. Your webcam will on, then your prompt will open. This kind of prompt will open. There is, you can see that the face and smile detector, the body is coming up on this, which we have done here. Similarly, what I was told you. Okay, means what is means you have to you can press the Q button. Means I am pressing the Q button, then it will close. It will stop, break the command. Then it will, you can see that the command is closed. You can close this thing. Means you can close this thing. Means it will take time, but means you can close the command only pressing the Q button. Okay. You can change the button also, whatever you are utilizing. Correct. So my webcam is off, and this things. Correct. This is the. I think so. We can sum up the session here. So what we have learned means how to use different platform. Means you can run this program also in your Jupyter or not Google Colab. You can run in the Jupyter notebook. Then you have to define location. Means because please make the file in the same section if you want to give run this program perfectly. Otherwise, you have to give the address where you have different files, because it requires 2 files, one app.xml and 2s.xml. We have to give the particular address of that the location where it is stored. Correct? There are 2 things. So we have learned about the Google Colab. Means when we have where we have to run the things online, so we can use the Google Colab platform. Then you can associate the Google Drive, so that you can effectively utilize the resources and you can save the data kind of thing. If you can use these things. And similarly, in Jupyter also, you can provide a command. It will open in the edge, then it will come command, and you have to give the address. Means you want to save. Please save this file, save as where the you have those files you can save. Means it is your choice, because you will do. So these are things, and correct. Now you can apply the machine learning, and you can take the you can show this program to your family and your friends, and you can check that means make a smile on their face. Okay. Now, if you have any questions and regarding this means whatever you are not understand and what you want to means any difficulty, whatever you have, I have tried my best, but if you have any difficulty.
Yeah, Mr. Rakesh, I have got an error in this line gray equals to CV2 CVD color frame. In the while loop, there's an error I am getting in the gray.
Means where you have run this program. Whatever
I have run in Spider.
No, it is the same program that I am running because
same program.
Any error. No, maybe you have changed some syntax or some kind of thing. You can download please again. Because that is a basic function. There is a basic function and it is a very old function that will not, I think, show any error kind of thing. Maybe you have checked spelling kind of.
No. Simply I have copied that file sent by you to my the folder of that particular Python program where it is there. And after that,
copy, not just open. You don't copy.
Yeah, I have opened it. I have opened it in Spider, and after the same program is coming up, along with the associated files 1F and 2F, 2W, the 2S.
Okay. Same download folder.
Yeah, the same folder I have copied.
You have opened the file face.py, or you have make your new file.
No, face.py. Face.py. I have opened face.py.
Maybe you have some change, I think so, because that is the default functions.
Otherwise,
can you tell me whatever error coming?
Can you just be on the line? I'll tell you the error also. Just 1 second, please. Yeah. I'm again running the program.
Yeah.
Because I have switched the camera off in the first time. Then again I have, Now it is saying that OpenCV, error is OpenCV 4.3.0. It has given a particular path name where, assertion is failed, source empty, in function CV, CVD color.
I think so your frame was not capturing, means your webcam is on. Means whenever
my webcam has got on. I've allowed it also because after initially when switching off the webcam, when I'm running the program.
See, Rakesh, I'm MK Datta. So it seems like the discussion is going on with a single participant. So please focus on a generic model. I mean, if he has a problem, we can take his things offline. We have to respect the time.
Yeah, thank you so much.
We need to close this by next 5 minutes time, Rakesh. There is a meeting after this. We have to join a meeting. Okay. And the guy who was actually asking this one, we will take it offline, and maybe there is some problem. But Rakesh, I will request you to close this session with the next 5 minutes time.
Okay.
Because there is a meeting at 1:30 which you are supposed to attend, and I am also supposed to attend.
Okay, sir.
And next we can always come back, and the queries we can resolve later.
Thank you.
Please, if any questions, you can ask any generic questions. I think so. You can ask. Otherwise, we will close. We run those programs. We will come back to you in upcoming days. Means we will show different programs, and tomorrow we will have a machine learning program, machine learning supervised learning sessions. Then we will show the SPM, support vector machines kind of things. Means please brush up your these kind of things. Means how you have to use the platform. Means where you have to tie the program. Means particularly in Google Colab also. Means you have to link the program so that you can work simultaneously with the means whatever program is going on your lecture session. You can run the program also. So please be ready tomorrow. If you have any problem, then you can ask. Otherwise, we will stop. So, sir, what is the should be specific laptop that I should buy for such kind of program? You can buy the simple laptop. Means you can say i3, i5, whatever you can choose. But whatever defines application that means, if you are going deep into the deep learning programming, that you have to buy the system which is having the good GPU, correct, and good RAM. If you have good RAM, then you can check the things. Okay. means don't any specific means if you have very small laptop, low budget by laptop, that means it will, the program that are deep learning program will run very slow. Means whatever program frames are capturing very fast, but it will capture very slow. So means that will not irritate you. Means that so you have if you have good program means you need some laptop which are having the GPU. The GPU the basic thing, then you can use this program. Yeah, you can run the Colab also, but what I have already done on the Spider. But whenever you run this program on the Google Colab, because this is using the webcam, there is no flexibility in the Google Colab. So if your interface kind of programming in the Google Colab, that will give you some error. It would better to be used kind of interfacing kind of program using your offline IDEs, means Spider or Jupyter. That will be. Thank you, everyone. That will come back to you. Upcoming days will be attached with it. Also, please stay hold, because I am sharing some sharing a Google. I will share a Google form link. Please fill that. That information will be needed. Means whenever if you have apply, means if you are go to the session with the Google Meet or some kind of things, means that information will be fill that information, means email ID and mobile number. Please carefully. We will communicate the information if we require. Please fill that information. We will circulate the program. I will share the link in the chat. Please don't close that. And I will closing the session for now for that. And please, I'm putting the Google form link. Please fill that link and please fill correctly. Correct. It will treat it as attendance, you can say, or you can say information communication pattern. So you can please stay here, and I will sharing the link. Thank you. Have a good day.
Thank you, sir.